Hello everybody, welcome to this course. Have you ever felt like you spend hours in Excel, building reports and updating files, but are struggling to get the insights that you need? You're not alone. Many finance professionals work incredibly hard, but not necessarily in the most efficient or the smartest way. And the truth is that the difference between a good analyst and a great one comes down to how well do they use the Excel or other analytical tools. This course is designed for finance professionals who want to work smarter. Whether you're already in FP&A or you're coming from controlling, accounting, or reporting background, this course is going to give you the tools to elevate your analysis and automate your workflows. Even if you're not in finance, but want to master Excel's professional grade skills, you'll find this course practical and relevant. By the end of this course, you're not just going to improve your Excel skill, you'll gain confidence, you'll feel more in control of your data, empowered to lead the conversations, and feel proud of the impact that your analysis can make. We'll work through real-world FP&A problems, from building forecasts, analyzing variances, consolidating data from multiple sources, and scenario modeling. I've demonstrated every concept in this course step by step. I've also provided the exercise files for download so you can follow along and practice. So if you're ready to move beyond basics and build Excel skills that truly drive decision making, then let's get it started. Before we dive into the lessons, let's quickly talk about the prerequisites for this course, so you know exactly what to expect. Since this course is designed for finance students, graduates, and professionals, I'm assuming you already have some basic familiarity with Excel. But if you're completely new to Excel, that's also not a big problem. Module 2 and 3 of this course include a refresher on Excel formulas and skills that will help you get up to speed quickly. Apart from that, to get the most out of this course, it will help if you have basic math and arithmetic skills, some background in finance. For example, if you understand what is a P&L, what is an income statement, what does it mean by variance analysis, that will be really helpful. But this isn't mandatory though, because I'll be explaining these concepts in detail as we go along. My goal is to ensure that by the end of this course, you feel confident handling any FP&A task in Excel, no matter where you're starting from. The course is divided into two parts. Part 1 focuses on building Excel and data skills. Part 2 applies those skills to real-world business challenges. Modules 1 to 4 belong to Part 1, and Modules 5 to 8 make up Part 2. The course is designed to take you from foundational Excel skills all the way to advanced FP&A applications. Just a quick heads up before we begin. Here on YouTube, I'm uploading the first 4 modules as a preview so students can get a good introduction and see what the course is all about. If you'd like to continue learning and get access to all 8 modules along with the exercise files, you can sign up for the full course using one of these links. The first link is a free coupon, it's limited time and limited seats, so grab it while it's there. If not, then you can use the second link, which is a discounted price. Now let's quickly walk through the details of each module. Module 1 is Introduction. This is where we are right now. We're going to cover fundamentals of FP&A, its role in the organization and the corporate world, how it supports decision making, and also a brief outline of the course structure. Module 2 is Essential Formulas and Functions. We'll start by building a strong Excel foundation. You'll learn the most commonly used formulas and functions every analyst must know. If you're already comfortable with Excel basics, feel free to skim through this module, but I recommend a quick refresher to ensure consistency with the later lessons. Module 3 is Data Tool for Analysts. In this module, we'll explore Excel's tools that help you organize, validate, and analyze data, including data validation, drop-downs, conditional formatting, custom formatting, sorting, filtering tricks, and pivot tables. Again, some of you might already be familiar with these tools, so you can move faster through these lessons if needed. Module 4 is Excel for Automation. This is the fun part. Now we move from the manual work to automation. We'll deep dive into powerquery to clean and transform data efficiently, and then explore Power Pivot and DAX bases to build dynamic analytical models. After that, we move to Module 5, and this marks the start of Part 2, that is application part. Module 5 is P&L consolidation and currency handling. Here we'll apply what we've learned in Part 1 and consolidate P&Ls from multiple entities operating in different countries with different currencies. You'll learn about the concept of reported versus constant currency reporting and how to ensure consistency in exchange rates. Module 6 is the variance analysis. This is the backbone of the FP&A. FP&A professionals spend a large amount of their time comparing numbers across different scenarios. actual versus budget, this year versus last year, and so on. Using the skills from part 1 of the course, we'll learn how to approach variance analysis systematically. You'll see how to move from manual variance tables to fully automated models that instantly explain what's driving the performance. But variance analysis isn't just about subtracting numbers, it's about understanding the story behind the change. We'll not only calculate the variances, but also break them down into price, volume, and mix components to uncover the true drivers of performance. By the end of this module, you'll not only know how to calculate variances, you'll know how to do it smartly and how to interpret those variances. Module 7 is about forecasting and budgeting. This is another core and often the most challenging area of FP&A role. From data management perspective, it can feel overwhelming because FP&A teams gather inputs from nearly every department of the organization and consolidate all of that data into one summary financial picture for the management review. But there's a good news. Using the automation and data skills you've learned in part 1, we'll turn this challenge into a walk in the park. You'll learn how to design input templates, collect and clean data from multiple departments, and use powerquery to consolidate everything into dynamic refreshable budgeting models. Since this part of the FP&A involves working closely with other teams, we'll also touch on the people side of FP&A. That is, how to collaborate effectively across teams during a budgeting cycle. Module 8 is about sensitivity and scenario analysis. This is your FP&A skills reach the strategic level. Once you've built your first cut forecast, management will inevitably ask you, what if sales grows by 2%? What if the inflation is lower than expected? What if exchange rates move in our favor, etc.? Manually testing each of these scenarios can feel almost impossible, but by this stage of the course, you'll have all the automation tools you need to make it effortless. We'll learn how to build dynamic scenario models that instantly adjust results based on key assumptions. You'll be able to create best case, worst case, and base case forecasts in minutes, not in hours. By the end of this course, you'll not only know Excel, you'll know how to use it like an FP&A professional to automate, analyze, and communicate insights that drive business performance. So let's get started. In most large organizations, you'll find a dedicated FP&A function, short for financial planning and analysis. The need for FP&A becomes even more important when the organizations are spread geographically or have multiple divisions. Because at the division level, they usually have local finance controllers who work with the business teams to help them manage the day-to-day financial operations and build their local budgets. But at a corporate level, leadership team needs one central function that can consolidate all of these budgets, provide a bit of a structure to the information, and tell the overall financial story of the organization. And that is where the FP&A comes in. Every public company reports results to its investors and provides an outlook for the future performance. That outlook is built on the financial plans and budgets that are developed by the FP&A teams. Once those plans are finalized and communicated, they kind of set an expectation both for the internal management as well as for the stock market. When the actual results come in, FP&A's job is to analyze performance, compare actual versus the plan, understand the reasons for the variances, and help management decide how to bridge the gap. In many ways, financial markets judge the companies on how well do they deliver on their commitments. And the managements of these companies rely heavily on FP&A to first set those commitments, then monitor the performance, and then drive the accountability. That's why FP&A is not just about numbers or formulas. It's a blend of business understanding, storytelling, presentation skills, and people management. But all of these 4 aspects are built on the foundation of analytical rigor and data expertise. And that's going to be the focus of this course. While we will primarily build mastery in Excel, because that's the tool that you're going to be using on a daily basis, but I'll also touch base upon broader skills and thought processes that make FP&A professionals successful in their role. By the end of this course, you won't just know how to use Excel, you'll understand how to use it to think, analyze, and communicate like a strong finance professional. Welcome everyone to Module 2. In this module, we'll explore some of the most commonly used formulas and functions that every analyst should know. We'll start with the arithmetic function to perform quick calculations. Then we're going to move to the logical functions like if, and or to help you make decisions inside your models. We'll also explore the lookup functions like xlookup, vlookup that allow you to fetch data efficiently. After that, we'll explore text functions that will help you clean and format your data, and the date functions that help you work with date-based or time-based data. Later in the module, we'll also dive into array functions like filter, unique, sort to help you work with dynamic datasets. We will work with named cells and ranges, a simple but powerful way to make your formulas easy to read and manage. Towards the end of this module, we'll work on a mini project where you apply everything that you've learned so far in a practical exercise. Mastering these functions will set a strong foundation for the next part of this course, where we'll start building advanced financial models step by step. If you already feel confident with these functions, you can feel free to skim through this module, but I still recommend following along for a quick refresher. You might pick up a few new tricks or shortcuts along the way. Alright, let's get started. In this video, we will learn about the sum functions in Excel. We will cover three types of sum functions: sum, SUMIF, and SUMIFS. I've also provided an exercise file that you can download and use to follow along. The sum function, as the name indicates, adds up a given range of numbers. Here on the first sheet, I have a table with the salesperson name, month, and sales amount. Let's say we want to find out the total sales amount of all the salespeople combined. We can do that by using the sum function. I'll write the sum function and then select the entire range of numbers that I want to be added. Then I'll close the bracket and it will give us the total. Next, let's move on to the SUMIF function. The SUMIF function is slightly more advanced. It adds the numbers that meet a specific given condition. For example, in the same table, instead of summing the sales for the entire sales team, let's say we want to find sales only for Ava Brown and James Anderson. This is where the SUMIF function comes in. The SUMIF function takes in three arguments. The first argument is the range. This is the column that contains the criteria values. So in here, we're going to provide the column that contains the salespeople name. The second argument is criteria. This is the condition that we want the formula to check against. So we will provide a reference to the name of the salesperson whose sales we want to get totaled. The third criteria is sum range. This is the column with the numbers that we want to total if the condition is met. So here, I'm going to select the sales amount column. Close the bracket, press enter, and we're going to get the sales value for Ava Brown. Now we can copy this formula and paste it down. However, we have to be careful because if we just copy and paste the formula, the ranges that we have provided in the formula will also shift as well, unless we lock them with an absolute references. So what I'm going to do is delete this formula, go back to the formula that we had put in for Ava Brown, lock the cell references to absolute references using the F4 key or just placing a $sign. Now we can copy and paste the formula down for James Anderson as well. Now let's move to the next sheet and look at the SUMIFS function. The SUMIFS function adds the numbers that meet two or more conditions at the same time. For example, let's say we want to find the sales number for Ava Brown and James Anderson, but only for the month of February. This means that we need to evaluate two criterions over here, the salesperson name and the month name. So let's type in the SUMIFS function. This function takes in at least three arguments. The first argument is the sum range. That is the column with the numbers that we want to be totaled. So here, I'm going to provide reference to the column containing the sales numbers. The second argument is criteria range 1. That is the column that contains the values for the first condition. I want the formula to first check if the salesperson name is Ava Brown or not. So my criteria range 1 will be the column that contains the names of the salespeople. So it will be the first column of this table. And the third argument is the criteria 1. So in this case, I need to provide the name of the salesperson for which I want to find out the sales, and that is Ava Brown. Now, if we had only one criteria to be evaluated, we could have actually closed the formula here and press enter, and that would have worked fine. But in our case, we have one more criteria that we want to be checked, and that is the month name. So I'm going to put in a comma, and then for criteria range 2, I'm going to provide a reference to the column that contains the month names. And then for criteria 2, I'm going to provide in the name of the month for which I want the sales to be total. Now let's close the bracket, press enter, and that should do the job for us. Similar to the previous example, we can drag the formula down, but before doing that, I'm going to freeze the references. Now I can copy the formula and paste it down. In this video, we will look into Excel's count functions. Count functions are useful for getting quick insights into your data. When building financial models, it's important to understand the structure of your data that you're working with. In the same file that we used in the last lesson, go to the count sheet. Here we have few exercises to practice and get a clear understanding of these functions. Excel has several count functions. We're going to practice some of the important ones in these exercises. The basic count function counts the number of all the cells in a given range that contain numerical values. So for example, if I apply the count formula to these 3 ranges, you will see that it returns the number of cells that contain numerical data. The count A function counts all the cells that are not empty. Irrespective of whether the cells contain numerical data, text data, date, or anything else, as long as they are not blank, count A will include these cells in the count. Count blank function, on the other hand, is the opposite of count A. It will count all the cells that are empty. Count if function works very similarly to SUMIF or SUMIFS that we learned in the last lesson. It counts the number of cells that meet a certain criteria. So let's say in this example, we want to count the number of cells that are not equal to an A. So I can put count if. In the first argument, I'll provide the range that I want to be counted, and then the criteria that I want the function to use in order to decide whether to count a cell or not. So here I'm going to put quotation marks not equal to an A. Then close, copy the formula, and as you can see, it has counted all the cells, empty, blank, everything included. The only cells that have been excluded from the count are those that contain an A. Next, we can move on to the second exercise. Here, I have a table which contains salesperson names, their sales target, actual sales made, and the difference between the two. From this data, I want to gather some quick insights. I want to know what is the total size of the sales team, how many salespeople achieved their target, and how many of them missed it. To get the total size of the sales team, I can use the count A function and select any column in the table. It will give me the size of the total sales team. To find out how many salespeople achieved their target, I can use the difference column. Wherever salesperson has achieved their target, the difference column is showing a positive number. So I can use this logic and apply it in a COUNTIF function. So I'll put the COUNTIF function, select the difference column as the range, and then in the criteria, I will put greater than 0. Likewise, to find the number of salespeople who missed their target, I can again use the COUNTIF function and just reverse the condition, which is less than 0. In this video, we will look into the min and max functions in Excel. These functions are straightforward but very useful in financial analysis. I'll head over to the min-max sheet in the arithmetic functions exercise file. The min function returns the smallest value in a range of cells, whereas the max function does the opposite. It returns the largest value in the range of cells. Here, I have a table which contains the salesperson name, their base salary, bonus percentage, and the calculated bonus. Let's say I want to find out what is the highest salary in the sales team? I can do that by using the max function. And inside the max function, I'll provide the range of values from which I want to find out the biggest number, and it will give us the highest salary. Likewise, if I want to find out the lowest salary in the sales team, I can do that by using the min function. These functions are also very useful when setting an upper limit or lower limit calculations. I'll unhide the two columns after column D. Now let's assume that our company has a policy to give bonus equal to 10% of the salary, but the bonus cannot exceed 12,500. In this case, if I want to calculate the final bonus for all of the salespeople, I can use the min function, provide the bonus cap and the calculated bonus as arguments, press enter and drag the formula down, and the function will return lower of the two values, that is 10% of the salary or 12,500. In this video, we're going to learn about the logical functions in Excel. Logical functions let us test conditions and return the results based on whether those conditions are met or not. In Finance or FP&A domain, these functions are helpful if you want to apply some business rules. For example, if you want to find out which employees have met their sales target and which have not, these functions can be helpful. We're going to cover three important logical functions: the if function, and function, and the or function. Let's start off with the if function. The exercise file for this video is provided in the resources section. Let's start off with the first sheet. Here, I have a table with employee names, their starting date, and their tenure with the company. Our goal is to check who is eligible for bonus. The company's rule is simple. If an employee has been with the company for more than 6 months, then they are eligible for bonus. So in this case, we can use a logical function to apply this rule automatically and identify whether each employee is eligible or not. We can use the if function in this scenario. The if function has three arguments. The first argument is the logical test that we want the function to evaluate. The second argument is value if true. That is the answer that we want the function to return if the logical test has passed. And the third argument is value if false, which means what is the answer that we want the function to return if the logical test has failed. So in this example, for the logical test, I'm going to put in the tenure greater than 6. This is the logical test that we want the function to evaluate. And if this logical test is passed, that is, the tenure is greater than 6, then we want the formula to return eligible. Otherwise, we want the formula to return not eligible. Close the bracket, copy the formula all the way down. And there we go. We have our desired results. Next, we're going to work with the AND function. The AND function checks multiple conditions and returns true only if all of them are met. If even one condition fails, the result is false. This is useful when you have to evaluate more than one logical condition in one go. Let's navigate to the next sheet. Here we have a table with similar data like we had in the last exercise. Now let's assume the company's policy is to give bonuses only to those employees who have spent more than 6 months with the company and have also exceeded their revenue target. Since we need to test both the conditions, we can use the AND function here. So in the column G, I'm going to type in the AND function. The AND function takes in the logical arguments, and as you can see, the syntax of the formula shows you can put in as many logical arguments as you want. The first logical argument I want to evaluate is whether the tenure is greater than 6. And the second logical argument that I want the function to evaluate is whether the actual revenue is greater than the target. Close the bracket. And it will return true wherever both the conditions have been met and false where even one of the conditions is lapsed. Now I can combine the results of this AND function with the if statement to see which employees are eligible and which are not. So I'm going to put in the if statement. I'll give the result of the end function as a reference. So if the value is true, I want to return eligible. If the value is false, I want to return not eligible. Note that it's not always necessary to calculate the AND function on its own in a separate column. We can also embed the AND function directly inside the logical test argument of the if statement. So for example, I will copy the AND function that I have written over here and go to the if statement. And in the logical test argument of the if statement, I'm just going to paste the AND function. And now I can copy and paste this formula. Even if there is no separate column for the AND function result, the if function works perfectly fine. Next, we're going to work with the OR function. Similar to the AND function, this function also takes in multiple logical tests. If any of the logical conditions is true, the OR function is going to return true. It only returns false when all the conditions have failed. In that sense, it kind of works as the opposite of the AND function. Let's switch to the next sheet. Here we have a list of departments along with their respective expenses. Our task is to flag departments that are either spending less than $150,000 or more than $300,000. This is a perfect situation to apply the OR function. So let's go ahead and type in the OR function. The first logical test is whether the expense is less than $150,000. And the second logical test is whether the expense is greater than $300,000. Copy the formula, paste it all along. So as we can see, the OR function has done its job. It has returned true wherever the department is overspending or underspending. Now we can wrap the results of this OR function inside the if function to clearly flag the departments that are crossing either the lower or the upper expense thresholds. So I'm going to type in if. For the logical test, I'm just going to provide reference to the cell which has the output of the OR function. And if it is true, then I want to return flag. Otherwise, I want to return OK. To wrap up this section, let's do a quick exercise that combines everything we have learned so far. Head over to the final sheet in this file. Now let's assume the company's bonus policy is as follows. For the employees in the sales department, everyone is eligible for bonus, regardless of their tenure or the revenue achievement. For the employees outside of the sales, only those who have spent more than 6 months with the company and also exceeded their revenue target are eligible. To solve this, we'll bring together all the three logical functions. First of all, we will use the AND function to identify the employees who have met both the tenure and the revenue performance criteria. So I'm going to type in and for the first logical test, I'm going to evaluate whether the tenure is greater than 6 months. And for the second logical argument, I'm going to evaluate whether the revenue is greater than the target. Close the bracket, copy, and paste. In the second step, we'll apply the OR function. In the first argument of the OR function, we're going to evaluate whether the employee relates to the sales department or not. And for the second argument, we will check if they have passed the AND test for tenure and performance, which we did in the last step. So I'm just going to give reference to the result of the AND function. Close the bracket. As you can see, the OR function has returned true for all the employees in the sales department. For employees outside of the sales, it has returned true only when both the conditions are met. That is, having more than 6 months of tenure and achieving the revenue target. Finally, we can wrap the result of the OR function inside the if function to clearly determine and identify which employees are eligible for bonus and which are not. So I'm going to write an if statement just before the OR statement. In the logical test of the if statement, we're going to key in the OR function that we had already written. And if the answer of the OR function is true, we want to return back eligible, comma. If the answer is not true, we're going to return not eligible. So in this section, we explored some powerful logical functions and saw how they can be combined to handle real-world business rules. Next, we're going to move on to the lookup functions, which will help us retrieve and connect our data more efficiently. We'll start by understanding what the lookup functions are, where lookup functions are used, and why they matter. Then, we will walk through some simple examples using VLOOKUP, HLOOKUP, and XLOOKUP functions. We'll also cover more advanced cases like how to look up where there are multiple lookup values, and also how to handle errors in an efficient way. So what are lookup functions? At a very basic level, these functions help you find a value from one table, which we call the source table or also the lookup table, and bring that value into another table, which is also called the target table. Let's jump into a few examples to see how it works. Let's first navigate to the basic VLOOKUP sheet. Here we've got two tables, the lookup table and the target table. The lookup table has two columns, the salesperson name and their respective sales amount. The target table has the same two columns, but here we have names of only three salespeople, Jacob, Michael, and Andy. Our objective here is to pick up the relevant values of these employees from the lookup table and bring it into the second column of the target table. We can achieve this result via the VLOOKUP formula. Let's go ahead and type in the VLOOKUP function. The VLOOKUP function has four arguments. The first one is the lookup value. This is the value based on which we want the function to perform the lookup. So in this example, I'm going to select cell B4, which contains the name of the salesperson. Second argument is the table array. In our example, this refers to the lookup table. Or in other words, it refers to the table from which we want the function to retrieve the value. So here, I'm going to select the table from where I want the function to retrieve the value, which is the lookup table. The third argument is column index number. Here, we need to input the column number from which we want the function to retrieve the result. I want the function to bring in the sales value. The sales value is in the second column of the table array that we have provided to the function. So I'm going to put in 2. And the last argument, which is optional, is the range lookup or the type of match. This basically means whether we want the formula to find the exact match of the lookup value or we can allow some level of estimation. For now, we want the exact match, so I'm going to select false. Now I'm going to close the bracket and it will retrieve the right value for us. Now I want to drag the formula for rest of the employees, but before that, I'm going to freeze the table array that we have provided to the function. And after that, I can copy and paste the formula to the rest of the cells. Before moving on, I want to highlight a very important watch out. It's a mistake that many people often make, and it's related to the selection of the table array. The table array we provide to the function should not always be the full lookup table like we did in this example. Instead, you have to select the table range very carefully such that the first column of your table array should be the column that contains the lookup value. Let me explain this further with the help of an example. I'm going to remove the formulas that we had put in. And now let's assume our lookup table had 3 columns. The first column was salesperson code. Now let's apply the formula again. I'm going to select the lookup value. And for table array, I'm going to again select the entire lookup table. And you'll see that the formula will not work. This is because the VLOOKUP function tries to find the lookup value in the first column of the table array provided. In the first column of this table array, there is a salesperson code and not the salesperson name, so the formula throws out an error. If we correct it, that is, I'll select the same 2 arrays that we selected before, and I'm going to give the column number 2, it will give us the right results. Next, we are going to look into the HLOOKUP function. Let's navigate to the HLOOKUP sheet. HLOOKUP basically is the mirror image of the VLOOKUP function. So if you have a clear understanding of VLOOKUP, HLOOKUP should be a walk in the park. In simple terms, HLOOKUP is used when your lookup table is arranged in a horizontal format. Like you can see in this example, we have the same exact data as we had on the previous page. It's just transposed and arranged in a horizontal manner. So if we want to retrieve a value from this lookup table, we can use the HLOOKUP function. So let's put in the HLOOKUP. The syntax of the HLOOKUP function is also very similar to the VLOOKUP. First, we have got the lookup value, for which I'm going to provide the salesperson name. Next, we have the table array, for which I will select the horizontal table from which I want the function to retrieve the value. Next, we have the row index number, and this is one of those aspects which is different in HLOOKUP function versus the VLOOKUP. In VLOOKUP, we had the column index number in the third argument. Here we have the row number. So in this case, the resultant value, that is the sales amount, is in the second row of the table array. So I'm going to put in 2, and I want the formula to retrieve an exact match of the lookup value. So I'm going to put in false, and there we go. Again, I can freeze the ranges by pressing the F4 key on my keyboard and drag the formula down. Next, we're going to look into the XLOOKUP function. XLOOKUP does the same job as VLOOKUP or HLOOKUP, but it's incredibly simple and flexible. Let's navigate to the XLOOKUP sheet. Here we have the same dataset as our first exercise on VLOOKUP. Let's try to solve it using the XLOOKUP function. So let's type in XLOOKUP. XLOOKUP function has a total of 6 arguments, but only 3 of them are mandatory. That is lookup value, lookup array, and resultant array. For lookup value, we will again provide the salesperson name. For lookup array, we will give reference to the column that contains the lookup values. So in this case, it will be the first column. And for the return array, we will give reference of the column that contains the resultant values, or the values we want the formula to bring in for us. And in this case, it's the sales amount column. Let's close the formula, and there we go. One important watch out here is that the size of the lookup array and the return array should be exactly the same. Otherwise, the formula can throw an error. For example, here, I'm going to change the size of the lookup array. I'll make it smaller, hit enter, and you can see it's giving an error. So let's do a quick comparison of the XLOOKUP function with the traditional lookup formulas. First of all, as we saw, XLOOKUP has a much simpler syntax than the traditional lookup functions. Secondly, XLOOKUP can retrieve values from both the direction. The traditional lookup functions are restricted and can only look up value from one direction. Let's learn it via an example. I'm going to copy and paste the same exact data down. And this time around, I have flipped the lookup table such that the first column is the sales amount and the second column has the salesperson name. Now, if I want to retrieve the sales amount from this table, I cannot do it using the VLOOKUP function. Let's try it out. So I'm going to put in the lookup value, select the table, and it doesn't work. This is because the VLOOKUP function picks up the resultant value only if the resultant value is on the right-hand side of the lookup value column. In this case, the sales amount, which is the resultant value, is on the left-hand side of the lookup column, so the VLOOKUP will not work here. However, XLOOKUP can do the job for us. I'm going to use XLOOKUP again, put in the lookup value, select the lookup array, which in this case is the second column. I know the headings are flipped around, so don't worry about that. And then the return array will be the sales amount. There we go. Coming back to our comparison, a third advantage of XLOOKUP is that it has inbuilt error handling function. Whereas for traditional lookup formula, we have to do some workaround to handle the errors. We'll look into it in more detail towards the end of this video. Now the question is, if XLOOKUP has so many benefits, why do we really need to learn about VLOOKUP or HLOOKUP? Well, the answer is that if you're building a new Excel sheet or a model from scratch, you can always use the XLOOKUP function. It's far easier and flexible. However, it's important to have some awareness of VLOOKUP function or the legacy formulas. Let's say if you come across an old Excel file which was built 8 to 9 years back, chances are high that it will still have the VLOOKUP formulas. Therefore, it's always good to have the understanding of the legacy functions, but if you're building something new, feel free to use XLOOKUP always. Next, we're going to work through a more advanced but a very common lookup problem, and that is when we have to look up based on two matching keys. So far we have seen that we looked up the values from the lookup table based on the salesperson name alone. But what if we want to retrieve the result based on the salesperson name as well as the month name? Let's go to the next sheet, which is called Advanced Lookup. And in here, we have a similar problem which I was talking about. I have a lookup table which has 3 columns: salesperson name, month name, and the sales amount. In the target table, in the first row, I want to bring in the sales amount for Emily, but only for the month of February. Let's see what happens if we use the XLOOKUP function like we did before. So I'm going to type in XLOOKUP, put the salesperson name for the lookup value. For the lookup array, we're going to provide the column that contains the salesperson name, and for the resultant array, we will select the sales amount. And as we can see, it brings the January number. This is because the function is not aware that we are looking for the February number. Therefore, it brings the first number that it can find related to Emily in the lookup table. To tell the function that we want to retrieve the data only for the month of February, we will need to apply a technique. And this technique involves setting up a helper column that contains a combo of the two matching keys. So I'm going to set up a new column called combo. And in this column, I want to combine both the salesperson name and the month. This can be achieved via the concatenate function. I'll first give the salesperson name, and as a second argument, I'll give the month name, and then I'll drag the formula down. Likewise, I'm going to set up a combo column in the lookup table. Another option to combine the two values is use the ampersand sign. So I'm going to select the salesperson, then put the ampersand sign and select the month. Next, we can apply the XLOOKUP function on this combo column. So I'm going to put in XLOOKUP. For the lookup value, I'll select the combo column that we have set up in the target table. For the lookup array, I'll select the combo column from the lookup table. And we're going to select the sales amount as the resultant array. And now we have the values for the month of February. We can freeze the ranges and drag the formula down. When using lookup functions, there's always a chance of formulas running into errors. For example, if they don't find the lookup value in the lookup tables. To make your Excel files look clean and professional, it's always recommended to use error handling techniques. Let's go to the next sheet called error handling. I have a similar data set over here. Let's apply a VLOOKUP formula to bring the sales amount from the lookup table. For the lookup value, I'm going to give the salesperson name. For the array, I'm going to give the table array. Give the second column an exact match. As we can see, the function is able to retrieve the sales value for Michael, but for others, it's throwing an error. This is because the other employees are not there in the lookup table. Now, of course, it makes your Excel look buggy and messy. To clean this up, we can use a function called ifError. I'm just going to copy this formula as we will need it later. Now I'm going to delete it and put in ifError. The ifError function takes in 2 arguments. The first argument is the formula that we want the function to evaluate. So I'm going to put in the VLOOKUP formula, which I had copied just now. If the formula returns a valid result, the ifError function will bring in that result. The second argument is value ifError. So if the formula that we provided in the first argument results in an error, the ifError function will return the value which we provide in the second argument. So here I will say not found. Now I can drag the formula down and it works. We can also put something else in the value ifError argument. That is the second argument. We can put 0, or if we want, we can put in blank. Now, a short while back, I just mentioned that error handling is much easier with XLOOKUP. So let's see how it's done. I will first apply the XLOOKUP function to this problem. The lookup value will be the salesperson name. Lookup array will be the first column, and sales amount will be the return array. So we see the same error again that we saw in case of the VLOOKUP. Now, instead of wrapping the XLOOKUP function inside of the ifError function, like we had to do in case of VLOOKUP, here I can simply use the built-in argument of the XLOOKUP function. Let's deep dive into the XLOOKUP function, and I'm going to put in a comma here. And as you can see, the fourth argument of the XLOOKUP function is called ifNotFound. This refers to what do we want the function to do if it doesn't find the lookup value in the lookup table. So here I would just put in not found and close the formula. And there we go. So basically, when it comes to error handling, XLOOKUP makes the life so much easier. In this section, we're going to learn about the text functions in Excel. The text functions are extremely useful when working with raw data. They allow us to clean, reshape, and prepare our information so it can be used for accurate analysis. In the FP&A world, we often deal with large, messy datasets, and the quality of an analysis depends heavily on the quality of the data. Mastering the text functions give us the ability to quickly transform our data into a usable format. We are going to cover several important text functions. As always, you can find the exercise files in the resources section. Let's begin with the len function. The len function counts the number of characters in a text string. To see this in action, here's an example. We have a table with the employee codes, and in our organization, we know that the employee codes are always 6 digits long. Now, to make sure that there are no errors due to incorrect typing or posting, we can use the len function to count the number of characters in each code. So let's write in the len function and give reference to the cell that contains the employee code. Close the function, copy, and paste it all the way down. Once we have these counts, we can take it a step further and wrap the results of the len function inside an if statement, and that way it will help us flag which employee codes are correct and which ones are invalid. So I'm going to type in the if statement, and for the logical test of the if statement, I'm going to evaluate whether the length of the employee code is equal to 6 or not. If it is equal to 6, we want to return valid. Otherwise, we want to return invalid. Next, we can copy and paste it all the way down. Let's move on to the next exercise and learn how to use the left function. Left, right, and mid are text extraction functions. They allow us to pull out a specific number of characters from a text string. The best way to understand them is through an example. So on this sheet, we have sales data by employee codes. Each employee code begins with a 3-letter country code followed by some random digits. Our objective is to find sales amount for employees based out of US and Canada. But to get this, we first need the sales amount by country code. Since the country code is always the first 3 characters of the employee code, we can use the left function to retrieve it. The left function takes in 2 arguments. The first argument is the text string from which we want to retrieve some characters. The second argument is the number of characters that we want to be extracted. So for the first argument, I'm going to give reference to the cell that contains the employee codes. And for the second argument, I'm going to put in 3 because we want to retrieve the first 3 characters. Close the bracket, copy, and paste the formula. Now that we have the sales amounts by country code, we can use the SUMIF formula to get the sales only for the employees that are based out of US or Canada. So let's type in SUMIF. For the range, we will provide the column containing the country codes. The criteria is the country code for which we want to get the sales, and the sum range is the sales amount. Let's freeze the cells. And there we go. In the next exercise, we're going to explore the trim function. When working with data exported from companies' ERP systems, you'll often notice unnecessary spaces in the text. For example, let's have a look at this dataset where I have employee names and their departments. For Sarah Lee, we have multiple spaces between her first and last name. Similarly, for Maria Gomez, we have a space towards the end of the name, and we have multiple spaces before her first name. If these spaces are not removed, they can affect the quality of your data and even cause errors in functions like lookup and sumif. Therefore, before you process your data further, it's always a good idea to clean it, and the trim function can help you in that. It removes all the unnecessary spaces. So for example, if there are spaces before or after the name, or if there are multiple spaces between the words, trim is going to clean them up. So let's go ahead and type in the trim function and give reference to the text string that we want to clean. Close the bracket and paste it. I'm also going to go ahead and clean up the department names as well. If you want to find out how many unneeded spaces the trim function has removed, we can calculate the length of the names before the trim and after the trim. So we can go and type in the length function, give reference to the name before the trim, and likewise length function and the name after the trim. As you can see that the trim function has removed a lot of spaces, and sometimes they might also not be visible with just a naked eye. Some functions that help us combine text from different cells into one. We're going to focus on two examples, the concat function and the text join function. Let's head over to the next sheet. At the top part of this sheet, I have a table with first name, middle name, and last name of some employees. Suppose we want to display the full name in the single cell here in column D. We can do this using the concat function. So let's type in concat. In the concat function, we can provide reference to the range of cells as an array, like I've done over here, or we can provide reference to each one of the cells individually, separated by a comma, like in this example. Now here the concat function has joined the names. However, let's suppose that we want to add spaces between the names. We can do that as well using the concat function. However, we will need to add these spaces manually between all the names. So let's say cell A2 refers to Emily and cell B2 refers to Johnson, and between A2 and B2 I want to put in a space. So I'm going to put in an extra comma, and I'll put a space enclosed in quotation marks. Likewise, between B2 and C2, I will put in another space, and again enclosed within the commas. So it does the job for us, but as you can see that when you need to add spaces or any other delimiter, the concat function can become a bit cumbersome. And that is where the text join function comes in very handy. In the column E, let's try to achieve the same result using the text join function. Let's type in text join. The first argument of this function is the delimiter. In our example, it is a space. So I'm going to provide a space enclosed in a quotation mark. The second argument asks for whether we want to ignore the empty cells or not ignore them. So let's select true for now. And a second later, we'll see how important this can be. And then in the next argument, we need to provide the list of text that we want to be combined. Again, in this function as well, we can provide the list of text as an array. Close the bracket, and that's it. Now there's an important feature of the text join function which I want you guys to know. Let's go ahead and remove the last name in the first example. And let's copy the results of the concat function and the text join function as values somewhere on the side. This is the result of the concat function, and this one is the text join function. If you'll go and deep dive into the concat function's result, you will see that there is a space at the end. And that is because the concat function is combining all the inputs that we have provided up until the second space, even though the last cell is empty, but is still counting the space that was provided before it. However, the text join function is intelligent in that sense. When it sees that the last cell is empty, it will automatically remove the delimiter that comes before it. To drive this point home, let's look at another example. Here we have columns for department, scenario, and month, and we want to combine them into one cell separated by a space and hyphen. Using the concat function, we'll need to write the full formula, which is as follows. So I'll put in concat, the first text, then in quotation mark, space, hyphen, and space, and the second text, again, the delimiter that we want in between the text. And that's all. But with the text join function, the process will become much more simpler. I'm first going to provide the delimiter, which is a hyphen surrounded by a space. Put in true for ignore empty, and just provide the range of cells that we want to combine. And there we go. So this wraps up our lesson on the text functions. We've explored how to clean, extract, and combine text to make our data ready for analysis. There's one more very important function that we need to cover, and that is called the text function. But we're going to cover that in a later lesson. First, we need to learn about custom formatting, which we are going to do in an upcoming lesson. And once you have a good understanding of that, then the text function is going to make a lot more sense. In this video, we're going to learn about date functions in Excel. These functions make it easier to work with and analyze date and time data. For example, calculating difference between the two dates or extracting the month or year from a given date. The today function, as the name suggests, returns the current date. It's quite useful when you want to build dynamic calculations based on today's date. For example, here I have a data set with a customer name, receivable amount, and the due date. To check if the amount is overdue, I can use the today function to return the current date. So I'll type in today and just close the bracket, format the data as a short date. So as you can see, the function has returned the today's date. Now I can calculate the difference between today's date and the due date and convert it into a number. I can drag the formula down. So for each line, the calculation here is now showing how many days have passed since the due date. Now to classify the data, I can use the if statement, where I can say wherever the days since the due date is greater than 0, which means a positive number, I want to return overdue. Otherwise, I want to return not due yet. So for example, Emily Johnson, the amount was due on 28th July 2025. Today is 13th September 2025, so it's been overdue since 55 days. But Olivia Smith will fall due on 15th October, and it's not been due yet, so there are 32 more days to go. Let's take a look at one more example. Here I have a data set containing two columns, transaction date and the amount of transaction. I want to find out how much was the total amount for the year 2025 and 2026. From our SUMIF lesson earlier, you already know that if we had a column in this data set that contained only the year number, we could have easily used the SUMIF function to calculate totals for a given year. But right now, we do not have a specific column which shows only the year number. We just have a column that shows the full date. So in this case, we can extract the year number from the date using the year function. So let's go ahead and type the year function, give reference to the date, copy the function, and paste it down. Now, using the year column, we can apply the SUMIF function and find the sum for a given year. Likewise, if we want to summarize the data by month, we can use the month function. The function will return the month number from the given dates. In this video, we're going to learn about the array functions. The functions we've learned so far in this course return a single value as an output. Array functions, on the other hand, can return a range or a list of values as an output. This makes array functions a very helpful tool when you're building dynamic dashboards or models where you anticipate new data to come in very frequently and you need a setup that automatically accommodates for new data. In this video, we're going to go through the basics of some commonly used array functions. We're going to start off with a filter function. The filter function helps filter the data. Here I have a data set which contains 3 columns: department, month, and expense. Let's say I want to filter this table and only bring out the data related to the marketing department. I can achieve that using the filter function. So I'm going to write in the filter function. It has 2 mandatory arguments. In the first argument, I need to provide the entire table or the data set or an array that I want the function to work with. So I'm going to provide cell A2 to C73. The second argument asks for what parameters we want the filter function to include in the output that we want to generate. I want the function to return only those rows in this table where department name is marketing. So to input that into the formula, for the second argument, I'm going to select the column of the table that contains the department name. So that is cell A2 to A73, or the first column of the array. And then I'm going to put the equal sign and put marketing. The third argument is optional, so we're going to leave that. And as you can see, the function is going to return the filtered table with only the data for the marketing department. Now let's say if I want to put in multiple conditions and filter the data on multiple parameters, that is also possible. Let's say I want to return a table that only shows marketing department expenses and only shows those months where the expense is higher than 12,000, then we can also do that as well. In the same formula, first of all, I will enclose the first condition into brackets. Then I'm going to put an asterisk sign and create a second condition. For the second condition, I'm going to give reference to column C, or the third column, because this column contains the expense. And for the condition, I'm going to put greater than 12,000. So basically what the formula is doing over here is that it's taking the entire table from cell A2 to C73. It's looking at the first column, which is cell A2 to A73, and filtering out only the marketing department data. And then it's looking at column C and only gonna pick up the rows where the expense is higher than 12,000. And there we go, we have the answer. Also from this example, you would have noticed how array functions are different from the functions that we learned in the previous lessons. The previous functions, like SUMIF or lookup functions, return answer that can be contained in one particular cell. But array functions return an output that spans across multiple cells. This also means that for these functions to work properly, they will need sufficient space nearby in order to return the output. Let me explain by help of an example. Let's say I'll go to this cell and I'm going to put in some data here. Now in the filter function, I'm going to remove the second condition. Since we have removed the second condition, the filter function is now going to try to return all the rows from the array that relate to marketing department, which means that it will need more space to spill the data. Now if I press enter, it will return a spill error. And if I put my cursor on the spill error, it will give you a visual indication of what's happening. Basically, it's telling you that for the function to return the output, it needs all this amount of space. However, since there's already some pre-populated data there, the function cannot return the answer. If I go ahead and delete this data, it will return the result. To further solidify our understanding, let's work with a few more array functions. Let's say I want to get a unique list of department names from the first column of this table. I can do that using the unique function. So let's type in unique and give reference to the entire column. In future, if a new department name gets added to the list, let's say we add research over here, the function is automatically going to update the list as well. Now let's look into another example. Let's say I want to return this entire table, but I want it to be sorted in the descending order of the expense column. This can be achieved by using the sort function. So let me give a heading over here for sort function and write in the sort formula. In the first argument, I'm going to provide the entire table, which is cell A2 to C73. In the second argument, which is the sort index, I need to provide the reference to the column which I want the function to use to sort the data. So in this case, I want the table to be sorted by expense, and expense is the third column in the provided array. So I'm going to put in 3, and then I'm going to put in the sort order. I want to sort it by descending order. So I put in -1 and then close the formula. So as you can see, the function has returned the entire table, but this time it has sorted in the descending order of the expense. We can also bring in the first row. If I give the reference to the full array, including the headers, it will return the headers as well. So in this video, we've covered some basics of the array functions and how they differ from the traditional functions that return a single value answer. We also practice a few exercises to build familiarity. In part 2, we're going to take this further and apply the array functions in more detail when we're going to be building the models. In this video, we're going to learn about name cells and name ranges in Excel. Name cells make formulas easier to read and understand. They also simplify writing formulas, especially in large workbooks where you have multiple sheets and interlinked calculations. The best way to see their value is through an example. Let's open the exercise file called Name Cells and Ranges. In this file, on the sheet called Name Cells, I have a small data set. This dataset shows sales in US dollars for 4 products. Let's say I want to find out the sales values in different currencies, that is Canadian dollars, euros, and INR. Now one option, of course, could be to simply take the sales values in US dollars and multiply it by the exchange rates, and over here I have hard-coded the exchange rates. This setup does the job for us, however, it's not dynamic. That is, if the rate changes later on, we'll have to update every formula on this worksheet. A better approach is to store the exchange rates in particular cells and then link the formula to those cells. Let's go to the master data sheet. And over here at the top, you will see I have stored the exchange rates for different currency pairs at the top. Now I can go back to my name cells sheets. And instead of hard coding the exchange rate, I can multiply the USD values with the exchange rates that I have stored on the master data sheet. Likewise, I can do the same for euros and for INR. In this setup, if the exchange rate changes in future, I just need to change it in one place and all the other cells in the workbook that are impacted by the exchange rate will update automatically. So for example, let's say later on, the USD to Canadian dollar exchange rate changes to 1.4. I just need to change it over here, and the values here will update automatically. If I do Control-Z and back to 1.35, the values still keep on changing. So with that, we have made the sheet dynamic, but there's still one issue, and that is readability of the formulas. If another user looks at these formulas, they won't be able to understand what's going on because they don't know what is in cell C4 on the master data sheet or what is on cell C5 on the master data sheet. And if that sheet is hidden, or if there are too many sheets and the master data sheet is buried among many other sheets, it becomes even more confusing. One solution to this problem is to assign names to the cells where we have the exchange rates stored. So I'm going to delete these formulas first, go back to the master data sheet, and over here, I'm going to assign a name to each of the cells that contains the exchange rates. To assign a name, I will select the cell which I want to name, and with that cell selected, on the top left bar, I'll put in the name that I want to assign. So for USD to CAD, I'm going to put CAD underscore exchange rate. Likewise for Euro, it will be Euro under exchange rate. And then for INR underscore X rate. Once these names have been assigned, we can access the values stored against these names anywhere in the workbook. So for example, in this cell, if I write CAD exchange rate, it's going to give me 1.35. And this can be accessed anywhere in the workbook. So now let's go back to our name cells sheet. And since now we have already assigned names, we do not need to write the full cell addresses or references in the formulas. We can just write in the names that we have just assigned. So I'm going to multiply the USD value by the CAD exchange rate. Likewise for Euro, I'm going to multiply USD by Euro exchange rate. And same way for INR. Now, if some external users read these formulas, it's immediately clear what we are trying to do here. The formula shows that we're taking the USD value and multiplying it by the Canadian rate or the Euro rate. This not only improves the readability of the formulas, but it also makes writing the formulas much easier. As you can see that while I'm writing these formulas, I don't need to go back and forth to the master data sheet and see which cell do I exactly want to reference. I can just write in the name here and drag the formula. Just like we assigned names to single cells in this example, we can also assign names to range of cells as well. Let's see where this can be helpful. On the named ranges sheet, I have prior year sales by month, and I want to find out the forecast sales for the next year. On the master data sheet, we have a stored sales growth percentage forecast for each month. So to calculate the next year's forecast sales, we can simply take the last year's sales and multiply each month by its respective growth rate. Now, one option could be to name each month's growth rate separately. So for example, this cell I can name as January growth rate, this cell can be named as February growth rate, this one March growth rate, and so on. And then we go to the name ranges sheet and multiply each and every number from last year with this year's respective monthly growth rates. However, this would be quite tedious and time consuming because we have 6 months, and this is just an example. In real life, you can see even bigger ranges as well. So naming each and every one of them could be quite time consuming. So a better approach is to name the entire range of cells that contain the growth rates. So to do that, I will select the entire range that I want to name, and then I'm going to assign the name that I want. So I will put growth rates. Once this range is named, it can be accessed anywhere in the workbook. So for example, if I put growth rates here, it brings up the data. So this allows us to easily calculate the next year forecast by multiplying the sales range from the last year with the growth rate range. So let me just show you another example. So here we can have the growth rates, and now I can either multiply this by this, or to simplify the formula and set up even further, I can just select this entire range containing the sales by month of last year and multiply it by the growth rates. This shows only the increase. So if I want to find the forecast sales for next year, I'm just going to add 1 to the growth rates and close the formula. So there we go. We have the forecast based on the growth rates that we had on the master data sheet. In this video, we're going to work through a small project that will give you practice of all the skills you have learned so far in the previous lessons. Let's go ahead and open the file called Mini Project Bonus Calculator. In this exercise, we have to calculate the bonus amount that each employee is eligible for. We have the data for employee name, department, hire date, revenue achieved, revenue target, and their base salary. The bonus rules are as follows. For an employee to be eligible for bonus, they should have spent at least 6 months as at the end of the year. The performance percentage is calculated as revenue achieved divided by revenue target. The bonus percentage depends upon the performance percentage, and the bonus slabs are on the lookup table sheet. So if an employee has a performance between 0% to 90%, they get 0 bonus. If their performance is between 90 to 100%, they get 5% bonus. If the performance is between 100 to 111, it's 10%, and above 111% performance, the bonus eligibility is 15%. The bonus amount is calculated as the base salary multiplied by the bonus percentage, which we would have gotten from the lookup tables. And we also have a bonus cap, which is currently on the settings sheet in cell B4. Currently, it is set to 20,000, which means that no employee should get a bonus of more than 20,000. So let's start working through this problem. The first step is to calculate each employee's tenure, since that's the first eligibility criteria. We already have the hire date for each employee, and the year-end date is stored on the settings sheet. By taking the difference between these two dates, we can calculate the tenure in terms of number of days. So I'm going to take the year-end date and then subtract from it the hire date. So this employee's tenure is 333 days. Now we need the tenure in terms of number of months, so I'm going to keep it simple and just divide it by 30. I know it's not a perfect conversion, but for this exercise, an approximate value should work fine as well. As you can see, the formula is currently pointing to a cell on another sheet, that is the settings sheet, which makes it harder to read. To fix this, I'll go to the settings tab, and I'm going to assign a name to both the cells. So for the year-end date, I'm going to assign the name of year-end. And later on, we'll be using this cell as well. So I'm going to assign a name right from now and call it bonus cap. Let's go back to the bonus calculation. And instead of referring to settings B2, now I can refer to year-end. Next, I can drag the formula all the way down. Now, using the tenure information, we can find out whether each employee is eligible for bonus or not. And to do that, I can use the if statement. In the logical test, I'm going to evaluate whether the tenure in months is greater than or equal to 6. And if that is true, I want to return yes. Otherwise, I want to return no. Next, we need to calculate the performance percentage of each employee, which is quite simple. We just need to divide the actual revenue achieved with the revenue target. Based on the performance percentage, which we have just calculated, we can determine the bonus rate each employee is eligible for. The slabs are on the lookup table sheet, which we just saw. And we can use the XLOOKUP function to pick the correct slab for each employee. So let's go ahead and type in XLOOKUP. The bonus percentage depends upon the performance percentage. So for the lookup value, I will give reference to the performance percentage. For the lookup array, we can provide reference to the first column on this table. And for the return array, we'll provide reference to the column containing the bonus percentages. For this argument, we can leave it blank. And for the match mode, I'm going to go with exact match or next smaller item. Now let's close the formula and drag it down. Before dragging it down, I'm going to freeze the cells so they don't move along as we drag the formula down. Now let's calculate the bonus amount. For all employees who have completed at least 6 months of tenure, the bonus will be their base salary multiplied by the bonus percentage, which we have calculated in column J. We can set up this condition using an if statement. So let's write an if. For the logical test, we're going to check whether the eligibility is equal to yes. And if that's true, we want to return bonus percentage multiplied by base salary. Otherwise, we want the formula to return 0. Lastly, we need to apply the bonus cap, which means that no employee should receive more than 20,000. For this, we can use the min function. And inside the min function, we're going to provide the calculated bonus and the bonus cap. The function will return the lower of two values. So as you can see, here in this case, The employee was supposed to earn $22,500, but the bonus has been capped at a maximum of $20,000. Now let's navigate to the next sheet. Here, we need to find summaries by department of total revenue achieved, total revenue target, and the bonus amount. We can do that using the SUMIF function. For the sum range, I'm going to provide the revenue achieved column. For criteria range, we will select the department column. And for the criteria, we can provide reference to cell A2, which has the department name. I will freeze the columns, but keep the rows unfrozen so the formula can move around. Let's go ahead and do the same for total revenue target. I'm going to copy the entire formula, paste it over here. And also I'm going to just paste it in column D as well. The formula in column C is right now referring to revenue achieved column. We want to refer to column E, which is the revenue target. So I would change it to column E. And for the third column, we want the sum range of the formula to refer to column L. So here I'm going to replace column D with column L. That brings us to the end of this module. In this module, you'll learn the core Excel functions that will be helpful for any analyst. We covered arithmetic, logical, lookup, array functions, pretty much everything. We then tied it all together in a mini project and applied these skills to a practical scenario. If you're comfortable with everything we've covered so far, you now have a solid foundation to move on to more advanced analysis tools. In the next module, we'll step up and work with Excel's data tools like data validation, conditional formatting, and PivotTables. And this will help you to structure and analyze financial data more effectively. Hello and welcome to Module 3. Before we start building financial models, it's very important to first get to know our data that we're working with. This means understanding what's in it in our data, spotting out the errors or inconsistencies, and organizing it in a way that makes sense. In this module, we'll explore the Excel tools that help you do exactly that. We'll begin with data validation and drop-down list. Powerful ways to control data entry and make sure your data stays clean and error-free from the very beginning. Next, we'll learn how to control the appearance of your data using custom and conditional formatting techniques so that important patterns and insights stand out instantly. After that, we'll look into sorting and filtering techniques. These are very simple yet powerful tools to explore your data, focus on what matters, and spot the trends. And finally, we're going to wrap up this module with PivotTables, one of the most valuable tools for any analyst when it comes to summarizing and understanding the large data sets. By the end of this module, you'll be comfortable exploring, organizing, and preparing your data. This is an essential step before we move on to automation and transformation, which is in the next module. All right, let's get to work. In this video, we're going to explore the data validation feature of Excel. Data validation lets you control what data users can enter in a particular cell. For example, in this cell over here, I can only enter product A, product B, or product C. If I try to enter product D, it will not allow me. In the planning and budgeting domain, data validation can be useful in two ways. First is when you're collecting information from different departments for budgeting or forecasting, and you want to prevent data entry errors. Second is when you're creating dynamic dashboards and you want to give the users a flexibility to use drop-down options to slice and dice the data. We will look at both the examples briefly. In the first example, let's assume we are setting up a sales forecast sheet. We have a table over here with each salesperson name, and next to it we have columns for region, product, and revenue. We want to send this file to the sales team so they can give their inputs. If we share this file as is with the sales team, there is a high chance of errors. Someone might type in the wrong product name, Or they might misspell the product name. For example, instead of writing product A, they might write product AA. Or they might just put in some extra spaces. These type of errors are not easily noticeable, but they can cause bigger issues later on when you're trying to consolidate or summarize the data. So to prevent this, we can apply data validation rules to restrict the inputs and keep the data clean. In this example, let's assume that our company sells its product in certain regions, and the list of those regions is given over here on the list sheet. So on the data entry sheet, in the region column, I want to apply the data validation in a way that users are able to select only those regions which were on that list. So I will select the cell where I want to apply the data validation, go to the Data tab, and then select Data Validation. Next, we need to specify what type of validation do we want to apply. In this case, I want the users to be able to select a certain value from a given list of values. So I will select List, and then we need to provide reference to that list from which we want the users to be able to select from. So I'm going to select here, provide reference to the list of regions. Then click on OK. And now you can see that we have the drop-down list available. If we try to enter any other value apart from that, Excel will block it. Now there is one downside with this setup, and that is the drop-down list which we have created over here for regions, it does not auto-expand itself. For example, if I add a new region here in the main list, it does not reflect automatically in the drop-down list on the data entry sheet. And this is because in the data validation for this cell, the reference to the list is hard-coded. So one way to overcome this problem is to convert this list into an official Excel table. So with any cell in the list selected, I'll press Ctrl+T and then click on OK. Now inside this table, I can select the list of values that I want to pass on in the data validation and give that list of values a particular name. I'll name it as region dropdown. From our previous lesson, you now know that once this range has been named, we can access it anywhere in the workbook. So what I'm going to do here is that in the data validation for this cell, rather than hard coding this list, I'm going to provide reference to the named list which we just created, region DD, and then click on OK. Now we have all the names here, but the great part is if I add a new country here, it will automatically reflect in the dropdown as well. Now I want to apply this dropdown in all the cells for region, so I'm just going to copy this cell and paste it all the way down. So all the cells will have the dropdown restriction. Likewise, I can do the same for product as well. I will convert this list into an official table, and then within this table, I will name this range as product dropdown, go to the data entry, select data validation, select list, and in the list, I will put product dropdown range. And it works. Ctrl+C and paste it all the way down. Again, to check if it's working properly, I will add product D to the list, and product D should be available over here as well. Once the data validation has been set up, we can now share this file with the sales team and be rest assured that there won't be data entry errors. Now let's assume the sales team has filled in their forecast and we have received the completed sheet. Now we want to set up a summary table for ourselves, which looks something like this. I want to be able to input the region name and the product name, and once I do that, I want to be able to see the sum of total revenue related to those region and product. In the yellow cell, I can use the SUMIF S formula. In the sum range, I'm going to give reference to the revenue column. For criteria range 1, I will select the region column. For criteria 1, I will give reference to the selected region. For criteria range 2, we will give the column that contains the product names. And for the criteria 2, I'll give reference to the product that we have selected. So this number right now shows the total revenue for Canada for product B. If I change it to Australia, the number will update automatically. So this setup works quite well so far. However, if users are made to input the region name or the product names manually, errors can creep in, and we just saw an example of that. If I mistype or misspell Australia, we will get the wrong answer. To solve this problem, we can add a drop-down list to the region and product cells using data validation, so that users will only select the valid data. So here as well, I can create a drop-down as a list and give region drop-down as the allowable values. And over here as well, we can give list and put product drop-down as the allowable values. And now users can play around with the values as they like. So this works well. However, there is still one downside, and that is the data drop-down list over here shows all the regions, even those which do not have any sales or are not present at all on the data entry tab. For example, the data entry tab has no records for United Kingdom, yet it still appears in the drop-down menu. Ideally, we want the users to choose only from regions that exist on the data entry tab. That's possible, however, with a quick workaround. First of all, we'll need to create a list of unique region names from the data entry tab. We can do that using the unique function, which we learned about in the previous lesson on array functions. Inside the unique function, I will provide reference to the column that contains the region names, and that will give us the unique list of regions that are there on the data entry tab. Now, inside the data validation, I will give reference to this cell, which has the answer for the unique list of region name. And in front of the cell address, I'm going to place a hash sign. So as you can see, it shows the list of regions that are here. Later on, if I add United Kingdom to the list, that will also get reflected. Similarly, if I remove some countries from the list, let's say I'm replacing a lot of other countries with US, the list is going to update automatically. In FP&A and budgeting, you often compare scenarios. For example, comparing actuals P&L to the budget P&L, or comparing the sales volume to target. In these cases, it really helps to quickly spot the variances, for example, highlighting where the actual sales are falling behind target. Excel gives us two features to do this: conditional formatting and custom formatting. Conditional formatting highlights the cells based on the rules that we define. Custom formatting, on the other hand, controls how the values inside the cells are displayed. We're going to work through a few examples that will give us practice of both the features. Open the file named Formatting Exercises. On the first sheet, you'll see a dataset with the department name, actual sales, forecast sales, and variance. In the variance column, we want to highlight the cells where actual sales are lower than the forecast. To do that, I'm going to select the variance column. Then under the Home tab, I'm going to select conditional formatting, highlight cells rules, and then go with the less than feature. Here, I can define a rule to format the cells that are less than a certain value. And for that value, I'm going to put in 0 because I know wherever the variance column is less than 0, the actual sales are lower than the forecast. And I can decide on what type of formatting I want to give. I can select a light red background, I can select red text, or I can do some other formatting of my own. For now, I'll go with the light red fill and click on OK. As you can see, marketing and operations, where the actual sales were lower than the forecast, have been highlighted in red. Now we're going to try to achieve the same result using the custom formatting on the same set of data. So let's go to the next sheet. Before we build detailed rules with custom formatting, let's quickly review the basics. I have a random number over here, and suppose I want to add 1,000 separator to this number. With this cell selected, I'm going to press Ctrl 1 on my keyboard, which will bring up the cell formatting window. Under the number tab, I'm going to select custom, and then I'm going to select any format that I like. For now, I'll select this one, or maybe this one, and then click on OK. And as you can see, the 1,000 separator has been added. What's happening here is that Excel is using a format code, and you don't have to stick to the presets that are in this list. You can also create a format of your own to get a full control. So let's play around a bit with this. Let's say if I put just the hash sign, it will display the full number. If I just put a 0, that will also display a full number. So what's the difference between hash and 0? 0 forces a digit to appear. Even if the number doesn't have one, Excel will show a 0. So for example, here we have 5 digits. So if I put 5 zeros, of course, it will display the number like that. But if I increase the number of zeros, although there is no number in the cell, but since we are putting a 0, it will force a digit to appear. Hash, on the other hand, will not force a digit to appear. It will only show digit if it exists. Now let's say I want to add decimal to this number. First of all, I'm going to click OK, and then I'm going to put this number as 1, 2, 3, 4, 5, 6, 7, 8, let's say. Now again, let's open the custom formatting. This is the underlying number in our cell. If I only put a 0, it will not show the decimal. No matter how many zeros do I place, it will not. But if I put 0.0, it will show that first decimal. If I put 3 or 4 zeros, it will show as many decimal points as we put. Likewise, if I use hash, if I keep increasing the number of hash signs, it will still only show 3 digits after the decimal point, and that is because the underlying number in the cell only has 3 digits after the dot. As we just discussed, hash does not force a digit to appear. It will only make the digit appear if the underlying cell value has 1. As a good practice, always use zeros after the decimal point. And I will show you why that is. Let's say we have a few numbers over here. In this case, if I use hash after the decimal point in the custom formatting, numbers will look a bit weird and inconsistent. Because in these 3 cells, there are no digits after the decimal point. And if we use hash in custom formatting after the decimal point, nothing will display, which will make the numbers look inconsistent. But if we use 0 as the digit indicator, even if these 3 cells do not have any number after the decimal point, the overall column and range of values will look consistent. Now let's say I want to add 1,000 separator to this number. So I'm going to select this number, press Ctrl 1, custom, and now I'm going to put a hash sign, which will just return the number as is. Then I'm going to follow it with a comma, and 2 more hash signs with a 0 at the end. This is going to put the 1000 separators. If I want to trim the number down into thousands, I can add 1 comma towards the end, and that will trim the numbers into thousands. If I put 2 commas, it's going to trim the number to million. And after the 2 commas, I can put a dot and put 0. So the underlying number in this cell is still the same full number as shown here in the formula bar. However, due to custom formatting, it's appearing as 12.3 million, which reinforces the point I mentioned before. Custom formatting changes the appearance of the content of the cell. It does not change the underlying value of the cell. A great thing about custom formatting is that you can also combine text and numbers in the format that you develop. So let's say I want this number to appear as 12.3 million or M at the end. So I'm going to press Ctrl 1 again, and then I'm going to put in quotation mark million. That will make it appear as 12.3 million. Let's work with one more example. Here, let's say we have a range of numbers. I'm just going to put some of the numbers as negative. And let's suppose that I want the negative numbers to appear in brackets and the positive numbers to appear normally with a 1000 separator. In this range, I'm again going to select custom formatting, and I'm going to go with hash comma hash has 0. So that brings up the 1000 separator. Note that the negative numbers are still appearing with a minus sign, but I want them to appear inside a parentheses. I'm again going to select this column, press Ctrl 1, go to the custom formatting, and then I'm going to type in the detailed notation. The detailed notation for custom formatting can include up to 4 parts, separated by semicolons. The first part defines the format for the positive numbers. The second part defines how we want the negative numbers to appear. The third one is for zeros, and the last one applies to the text values. So let's build one ourselves. For the positive numbers, I'll keep the format as is because I'm happy with how it's appearing right now. Then I'm going to put a semicolon, and now the notation we will put in will apply to the negative numbers. So I'm just going to copy what we had put for positive numbers and paste it over here. But this time, I'm going to enclose it in parentheses. Then I'm going to put one more semicolon, and this time we're going to define how we want the zeros to appear. Let's put a dash for zeros, and then I'm going to put one more semicolon, and now we need to define how we want the text values to appear. So for that, I'm just going to put it not applicable. So now, as you can see, the negative numbers are appearing inside brackets, whereas the positive numbers are appearing normally. However, there is still one small issue, and that is the numbers are not perfectly aligned. If you see the positive numbers, the comma, the 1000 separator in the positive number is slightly on the right side, whereas the negative numbers have the comma skewed a little bit towards the left. And that is because the brackets are eating up some space. So to fix that, I'm again going to go into the custom formatting. And for the positive numbers towards the end, I'm going to put in an underscore and bracket. That slots in one space towards the end to cover for the bracket. So click on OK, and now all the numbers are aligned. Now let's say I want the negative numbers to not only appear inside the parentheses, but I also want them to appear in red font. So I can do that as well. In the second part of the notation, which represents the negative numbers, I'm going to put 2 square brackets, and inside of that, I'm going to put in red, and that will make the negative numbers appear red. If I want the positive ones to appear green, I can go to the first part of the notation, which defines the positive numbers, and at the start of it, I can put green inside brackets. I don't really like this shade of green, so instead of using just green, I would use color 10, which is usually a better shade of green. Also, as you know, we defined the notation for zeros and text values. So let's test them out as well. If I put 0, it appears as a dash. And if I put any text value, it appears as an A. So that was a quick walkthrough of the custom formatting basics. Now that you know how it works, let's apply it to our original exercise where we had a variance column. And in this variance column, we want the negative variances to appear in red and inside brackets, whereas for the positive values, we want them to appear normally. So I'm going to select the variance column, go to custom formatting, and put in the same custom formatting that we had just developed, that is for positive numbers. We're going to make them appear normally, semicolon. The negative numbers will be also same, but just inside the brackets. For the positive ones, we also want to leave one space towards the end so that the numbers are aligned. And for the negative ones, we'll put them in red. For the 0 values, I'm going to format them as blank. So let's click on OK. And there we go. Using custom formatting, we have formatted the variance column using a defined set of rules. Now that you have a good understanding of the custom formatting, it's a good time to learn the text function. The text function helps apply the formatting of your choice to a selected value. You can say it's an alternate to custom formatting. Let's continue with the same example which we saw in the last video. I have the variance column over here, and in the last video, as you know, we formatted it using the custom formatting. Now, rather than custom formatting, we can achieve the same result using the text function. The text function takes in 2 arguments. The first argument is the value that we want to format. So for that, I'm going to provide reference to the variance column. And the second argument is the custom formatting code, which we learned in the last video, which we want to be applied to the formatting of this value. So for the second argument, inside the quotation marks, I'm going to provide the code which I want to be applied for the formatting, and then press enter. Now, I can drag the formula down, and it should work. One important thing to note here is that the text function does not just change the appearance of the number like the custom formatting does, it actually converts the number into text displayed in the format that you have specified. To explain this further, I will sum up these values to which we have applied the text function, and as you will see, the sum formula will not work. This is because these values are no longer numbers. They are text values, but they look like numbers because we have reformatted them using the text function. Now the key question, what's the use of text function? This function is especially helpful when creating automated commentaries or explanations. For example, suppose that in our report we want to write a comment which says sales are higher by $2 million. This statement has 2 parts. First part is a plain text, and the second is a number formatted in millions with a currency symbol. Using the text function, we can create this comment in a dynamic and automated way. Let's work through an example to learn how. I'll go to the second sheet of this file. Here I have a dataset. In the first column, I have the employee names, and this is followed by a salary column, revenue, and growth percentage. In the next column over here, I want the following value to appear. Salary semicolon space, followed by the salary amount from column B, which is formatted with a 1000 separator and a $sign. As you might have guessed, we can achieve this using the concatenate function. So let's go ahead and try that. I'll put in concatenate. In the first part, I will put salary, semicolon and a space. And then in the second part, I'm going to give reference to the salary amount. As you can see, we have the values here, but the salary numbers are not properly formatted. And even if I correct the formatting of the salary column over here, the original column, it will have no impact on column E. Let's try it out. I'll go to the custom formatting and I'll format it with a 1000 separator. And towards the beginning, I will put a $sign. As you can see, the column B has been formatted correctly, just like I want it to appear, but it does not have any impact on column E. This is because when you use the custom formatting, it changes the appearance of the number, but the underlying number is still a bland 85,000 over here. If we want this value to be properly formatted, we will have to use the text function just right where we are giving reference to the salary amount. So I'm going to type in text. In the first argument, I'll give reference to the salary amount, and then I will put in the custom formatting with which I want this number to be formatted. Let's look at a slightly more complicated example. So here, let's say I want to bring in both the revenue as well as growth. So we can use the same methodology. We'll start with concatenate, write in revenue, semicolon, a space. Then in the second argument, we will use the text function, give reference to the revenue amount, and then the formatting of our choice, which will be something like this. Next, I'm going to give a space and then a separator, then a space again. Then we can write growth. And lastly, I want to show the growth percentage. So I'm again going to use the text function, give reference to the growth number. And this time, I want this value to be formatted as percentage. So I'm going to give this notation. Looks quite good. Lastly, let's also do a bit of formatting of the date. We haven't tried that so far in our lessons. So I'm going to concatenate. I'll write as of, and then one space. And then I'll put in text function. I'll select the date and I'll format the date as something like this. I think that should work. In this video, we're going to learn about sorting and filtering techniques in Excel. It may seem basic, but when you're building financial or complex models, it's often helpful to step back a little bit and get a bird's eye view of your data that you're dealing with. Understanding the overall characteristics like the range of values, the number of dimensions that you have in your data, it gives you a good context before you dive into the model building. We will be using one exercise file for this video. As always, if you would like to work along, you can download this file. In this dataset, we have department, expense type, month, actual expense, budget expense, and a few more dimensions. Let's say we want to prepare a short report comparing actual versus budget expenses by department. Before we start building this model or report, it really helps to explore the data. For example, how many departments do we have in this data that we're dealing with? What are the highest expenses, etc. Sorting and filtering tricks can help you get this overview information. To get started, I'll just click somewhere in the dataset and then apply filters using the short key Ctrl+Shift+L. Once the filters are applied, we can sort the data as we like. Let's start with a simple sort. Let's say we want to sort the data in the descending order of the actual expenses. So I can click over here and sort smallest to largest, or sort largest to smallest. Similarly, if I want to sort the data in the alphabetical order on the basis of the department name, I can click here and sort A to Z. This was an example of a simple sort. We can also do a multi-level sort, basically sorting based on two dimensions of the data. For example, I want to sort the data in the alphabetical order of the expense type first, and then once that is done, I want the data to be sorted in descending order of the actual expenses. Let's try to do that via the simple method that we just learned right now. So I'll sort the expense type A to Z. Now, if I sort the actual expenses largest to smallest, you will see that the sort on the expense type has disappeared. But what I want is that the sort on the expense type remains there, and then on the second level, it sorts the actual expenses largest to smallest. If you want to do that, we'll go to the Data tab and then click on Sort. And here we can add the sort levels. So first I'm going to delete. I'll add the first level where I would say I want to sort the expense type A to Z. Then I'll add another level where I will say actual expenses largest to smallest. Also, the drop-down buttons now indicate that there are two sorts applied. The first is sorting the expense type from A to B, and then within that sort applied, it's filtering the actual expenses from largest to smallest. You can also sort the data by color. So let's say I'm just going to apply some colors to some of the cells over here. Now, if I go into the sort menu, I will have the option to sort by color. Another important technique is the custom sort list. Let's say I want to sort the expense type column not alphabetically, but based on my own preference order. For example, let's say I want the salaries to appear first, then training, marketing, rent, travel, IT, and in the end, I want to see the other. If you will go to the sort button on the expense type column, you will only see the options for alphabetical sort here. But using the custom sort technique, we can sort the data based on our own preference. Again, we'll go to the Data tab, click on Sort. Add a sort level. Select expense type as the header that we want to sort by. Now, instead of selecting A to Z or Z to A, I'll go with the custom list. Here, I can create my own list. I will add this list and select this. Click on OK. Now, it's going to sort the expense type column based on this order. And as you can see, we have the desired result. Now let's move on to the filtering techniques. Filtering can help you slice and dice the data. It can really help you see only certain segments of the data that you're interested in. Let's say I only want to see those rows of my data set where the actual expenses are greater than 40,000. To do that, I'll go to the drop-down button, then click on Number Filters, select Greater Than, and then I'll put 40,000 here. And it will only show me those rows. Or let's say we increase the threshold, we make it 45,000. And you'll see the data has been sliced to only those relevant cells. Or let's say if I want to see only the top 10 items by actual expense, we can do that as well. So it really helps you play around with the data as you want. We'll do Control-Z. You can also apply filter on the text fields. Let's say I only want to see the data for the IT department. I'll click on the drop-down button and then just select IT from the list available. If the list is too long and I'm not able to find IT over here, we have a search box where we can also write IT and click on OK. That will also do the job. Let's say I want to see the data for both IT and finance. I'll just type IT is already selected. Now I'm just going to type finance, and then I will select this option which says add current selection to filter. This will add finance and keep the IT which was there already from the last filter. And you can see that it's showing us the IT and finance. If you want to remove the filter, we can select clear filter from department. Filter can also be applied based on the color. So for example, if you only want to see the colored cell, we can select that. Also, we can apply filter on date fields. So let's say we want to see the data only for the month of January 2025. I'm just going to select that and it will show me the relevant data. We can also combine the filtering and sorting together. Let's say I only want to see the data or rows for the marketing department, and I want them to be sorted in the smallest to largest order of the budget column. Then first, I'm gonna select only the marketing department data, and then I can apply sort within this data. So that was a quick tour of sorting and filtering tricks in Excel. These simple tools can give you instant insights into your data, like spotting the outliers or understanding the depth of your data. For example, how many departments are there, or how many expense types are we dealing with, etc. It's not about building the full model yet, but about understanding the shape of your data so that when you're building the model, you can do that with confidence. In this video, we are going to learn about pivot tables. In my view, this is one of the most important tools every analyst should know in Excel. Pivot tables let you quickly summarize and explore your data. And beyond that, they can also serve as the backbone of many dashboards, acting as an underlying source. We'll work through an example to see how pivot tables are used and why they are so powerful. Here, I have a dataset with actual and budget amounts, and we have the details for account, department, cost center, date, etc. Suppose that I want to find the totals of the actuals column by department. Based on the learnings from the previous lessons, you might have guessed that we can achieve it via the SUMIFS function. For example, I can write the SUMIFS formula, something like this. So this does the job, but when datasets get large, SUMIFS formula, or any formula for that argument, becomes less efficient and far less flexible. For example, if later on I change my mind and instead of summarizing the data by department, I want to summarize the data by account, or let's say by cost center, I will need to reconfigure and rebuild the entire formula. That is where pivot tables come in quite handy, and they solve this problem. They make it a lot easier to reorganize, resummarize, and drill into the data without rewriting the formulas. This gives you a lot of speed and flexibility. To create a pivot table, you'll have to select your entire dataset. Make sure there are no gaps in the columns of your dataset. And once the dataset is selected, go to the Insert tab and select Pivot Table and select From Table Range. I want to insert a pivot table on a new worksheet, so I'll select that option, click on OK. Once you have set up the pivot table, you will see a pane on the right side called Pivot Table Fields. This pane helps you structure, design, and manage your pivot table. In the top portion of this pane over here, you have a section which shows the list of all the columns or fields from your original dataset. So let's say if I go to my original dataset based on which we have created the pivot table, I can see that there are 7 columns, and the names of all those 7 columns are over here. At the bottom over here, we have 4 sections. We will see how to use them as we go along. Let's carry on the example which we just did a few minutes back. I want to see the sum of actuals column by department. To do that, I will drag the department field into the rows section. Then I'm going to drag the actuals field into the values section. There we go, we have the same result which we just achieved a few seconds back using the SUMIFS formula. Now let's say I change my mind, and instead of seeing the summation by department, I want to see the sum by account. I'll drag the department back into the top section, and then I'll bring in the account in the rows. We have the summation by accounts. Similarly, we can do it by any other field that we like. So for example, we can go with the cost center or any other field that we want to drag into the rows section. Just like we use the rows section to summarize the data with one dimension, we can use the column section to summarize the data on any other dimension. So for example, I'll put account in the rows section. So here I have the summary by account, and then I can put the department on the column section. And along the columns, we will have sum of actual amounts broken down by departments. Another cool feature of pivot table, which might not at all be possible with simple Excel formulas, is the grouping feature. Let's say I want to see the sum of actuals by month. I'm going to remove the department and also account as well. If I go to my raw data set, you will see that we do not have the month information in this data set at all. We just have raw dates. Yet still, if I drag the date field into the rows section, Pivot Table is automatically going to summarize it for us and group it into months. I can also revise the grouping on some another level. For example, if I want to group it by quarter, that is also possible. I'll right click on this, go to groups, and then create groups by quarters. We'll just collapse it. And you can see that it has been grouped by quarters. In pivot tables, we can also do multidimensional or multi-level analysis. It's also commonly called as the drill down feature. In the pivot table, I'll first drag account into the rows section. So that gives me the summary of actuals by account. Within the account, I want to see the breakdown by department. So for example, out of this revenue, I want to see which department is contributing how much to this revenue. To do that, I can drag the department just right next to account in the rows section. A plus sign will appear against each account. I'm just first going to right click on any one of them and collapse the entire field. The plus sign is still there. If I want to see the breakup of only the revenue account by department, I can click on this plus sign and it will show me the breakup. In the pivot tables, we can also change the type of aggregation. For now, you can see that while I have dragged the actuals field into the values section, pivot table is summing up the actual column. Instead of sum, if we want to aggregate in some other way, that is also possible. First, I'm going to drag out the department field and I'll just leave the account in the rows section. Now, on the actuals field inside the value section, I'm going to right click over here or click on this drop down, go to value field settings. As you can see, by default, the sum aggregation has been selected, but we can aggregate in many other ways, like we can take average, max, whichever we want. I'll go with count, and it will show us the count of rows for each of the account. I'll do Control Z, so it will return the summation. If we want to rearrange the fields or sort them, we can do that by simply dragging the fields individually, like I'm doing here. Within the pivot table, we can also slice and dice the data using the filter feature. There are two ways to add a filter to the pivot table. One is via the filter section on the pivot table fields pane. Other is via adding a slicer. Right now, we have a P&L based on a full data set. Let's say I want to filter this P&L for a certain department only. To do that, I can drag the department field into the filter section. This gives me a drop-down option at the top of the pivot table, which I can use to filter the data as I like. So let's say if I want to see the P&L only for the marketing department, I'll select marketing, and it will filter the data accordingly. The other option, as I mentioned, is to use a slicer to filter the data. I'm going to clear the filter from here. And also I'm going to remove the department from the filter section. And then I'll right click on the department field and add it as a slicer. Now within the slicer, I can select any department by which I want to filter the P&L. A key difference between a slicer and a filter is that a slicer can impact multiple pivot tables that are connected to the same data source. Filter, on the other hand, only applies to a particular pivot table. Let's understand why an example. I'll first remove the slicer, and then I'm going to create a copy of this pivot table and paste it over here. So now these two are separate pivot tables, yet they are connected to the same data source. Each of these pivot tables also have a name. To know the names of these pivot tables, you can place the cursor on any of them and then go to Pivot Table Analyze. This pivot table is called Pivot Table 2, and this one is Pivot Table 3. Also, just to differentiate between them, for the pivot table 3, instead of putting accounts in the row section, I'll put the cost centers over here. Now on the pivot table 2, I'm going to add department as a filter. Also on the pivot table 3, I'll add department as a filter. Now, if I filter the pivot table 2 for a given department, let's say marketing, it will impact the pivot table 2, but it will have no impact on the pivot table 3. In fact, for the pivot table 3, I can select any other department to filter this pivot table. Let's remove this filtering from both the pivot tables. Now, I'll go to the pivot table 3 or any pivot table that I want, and I can add department as a slicer. In the slicer, if I select any department, it's still only impacting the pivot table 3 but not the pivot table 2. However, since both of these pivot tables are connected to the same data source, I can have the slicer impact both of them in one go. With the slicer selected, I'll go to the Slicer tab. Then I'll click on the Report Connections. As you can see, the slicer is right now connected only to the pivot table 3. I'll check mark pivot table 2 as well. Click on OK. Now, if I select the marketing department, both the pivot tables are getting impacted by the same slicer. Due to this feature, slicers are especially useful for building interactive dashboards, in which when a user clicks on a particular button on the slicer, all the visuals that are connected to the same underlying data update instantly to reflect that selection. Another important feature which I want to cover is the calculated fields. As the name indicates, this feature helps you add new fields to your pivot tables via a calculation based on the pre-existing fields. So I'm going to remove the slicer, and I can also remove the second pivot table that we had added. And in this pivot table, I'm just going to also add the budget field into the value section. Here we have a P&L inside the pivot table which shows the actual amounts as well as the budget amounts. But it does not have a column which shows the difference between the two. And in the field of FP&A or budgeting, you will always find yourself doing comparison between different scenarios. Sometimes it's going to be actual versus budget, sometimes actual versus last year, and so on. So let's say I want to add a new column which shows the variance between actual results and the budget. We do not have the variance field in the underlying data set. However, that's not a big problem. We can calculate a new field using the pivot table calculated fields feature. With the pivot table selected, I'll go to pivot table analyze, and then under the option for field items and sets, I will select the calculated field. I will give name to this field of variance, and in the formula, I'll select actuals minus budget. Click on OK. And here we have the variance field added. As a last step, I will do some formatting. So with any of the fields selected, I'll right click, go to number format, and then within the custom formatting, I'll just select any of the presets. And I'll do the same for the other fields. With that, we wrap up our lesson on pivot tables. As you saw, pivot tables help you explore data from different angles in just a few clicks. For FP&A work, this flexibility makes them one of the most valuable tools in Excel. Hey everybody, congrats on completing Module 3 and welcome to Module 4. In my opinion, this module is the most important one in the entire course. In this module, we'll see how Excel can move from being a simple spreadsheet tool into an analytical engine, if it is deployed correctly. Up to this point, we've been working with Excel manually, cleaning data, formatting it, exploring it using traditional tools like sorting and filtering, pivot tables, etc. Now it's time to take things to the next level. In this module, we'll start learning how to make Excel do the heavy lifting for us. You'll see how to automate repetitive steps, connect and refresh data easily, and build smart models that save time and reduce errors. The purpose here isn't just to learn new tools, it's to think differently about how you work with data. Because once you master this new way of working and thinking, you'll be ready to tackle the FP&A challenges like consolidating P&Ls, analyzing variances, building the forecast in a much faster and more efficient way. All right, so let's get started. Over the next few lessons, we're going to be learning about a very important tool in Excel, which is called powerquery. Many people think of powerquery as an optional skill, but in my opinion, if you work with large datasets, it's no longer an optional, it's an essential tool to have. The flexibility and efficiency that it brings can save hours of manual work. Powerquery serves three main purposes. It lets you combine data from multiple sources, it helps you clean and transform the data, and the best part is, every cleaning or transformation step that you do is recorded so it can be repeated. And thirdly, because of the above 2 points, it automates your entire workflow, which means that you can create dynamic dashboards and reports that can update automatically whenever the new data is available. Over the next few lessons, we will work through several examples to build your understanding of powerquery. There are quite a few exercise files for this section. You can download them to work along. Let's go ahead and open the first file called powerquery basics. We will keep things simple in this first exercise. So I just mentioned that powerquery helps combine data from different sources. Before we see how powerquery does it, let's try to understand why would you ever need to do that. In the last video, we built a pivot table using a single dataset. Now imagine that data isn't all in one place like we had in the last video. Here, I have separate sheets for different departments, sales, marketing, and operations. The structure of the data, the columns, they are all the same as we had in the last video, but the data is split across different sheets. If we use the same approach as we did in the previous lesson, we could build 3 separate pivot tables, one for each dataset, but we will not be able to create a single consolidated pivot table in that way. That is exactly where powerquery comes in. It allows you to combine all these sheets into one dataset and build a unified pivot table. So let's go ahead and do that. In the first step, we will need to load each of these datasets into the powerquery editor. To do that, I will need to convert these datasets into official Excel tables. So I'll just place the cursor somewhere in the dataset, press Ctrl T. My table has headers, so I'll check that option and click on OK. I'll do the same for the other datasets as well. So we've got 3 tables now. This is table 3, which is operations. Table 2 is marketing, and table 1 is sales. Now we can load these tables into powerquery. First, we will load table 1. With the cursor placed anywhere inside table 1, I will go to the Data tab and then select the option from table range. Once we do that, a powerquery editor window opens up. There are lots of transformation and cleaning options available in this window. We will cover them shortly. Now that the table 1 is inside the powerquery editor, we need to repeat the same step with table 2 and table 3. So first of all, we'll need to exit from the powerquery editor. I'll click Close and Load, and then I'll select Close and Load to. There are a few load options available here. We will study them in detail later on. For now, let's select only Create Connection and click on OK. Once you do that, a pane on the side will open up that will show the list of all the active queries or tables that have been loaded. So for now, we have loaded only table 1. Now I'm going to repeat the same step with the table 2, which is marketing. And then with the table 3. So we have now loaded all the tables into Power Query Editor, but we still do not have a unified pivot table. To get a consolidated pivot table, we'll go inside the Power Query Editor again by double-clicking on any of the queries. And here we will need to create a new query that combines the three tables. So with any of the tables selected, and under the Home tab, I'll go to Append Queries and select the option for Append Queries as New. I will select 3 or more tables. Here we have an option to select which tables do we want to append or combine. So I'm going to select all 3 tables, click on OK. It will create a new table for us, which is called Append 1. We can call it Consolidated. In this table, in the Department column, you will have all 3 departments, which indicates that 3 tables have been combined. Now, when we are going to load this query, we will load it as a pivot table report rather than just only a connection, and we will load it on a new worksheet. Once that is done, you will see the same familiar pivot table fields pane on the right. We can create the pivot table as we like. So I'll drag the department into rows and actuals into values. The Power Query works in 3 broad steps. The first step is connecting to the source data. The second step is cleaning and transforming that data. And in the third step, we load the data back into Excel workbook. In the last exercise, we actually touched upon all of these 3 steps. First, we connected the Power Query Editor to each of the 3 source tables. In that case, the source was inside the same workbook where we were using the Power Query Editor. But that is not a requirement. You can also connect to other Excel files, databases, or even online sources like SharePoint or OneDrive. The second step is cleaning and transforming. This is a huge area with a lot of options. In our last example, we did one transformation step, and that is when we combined the 3 source tables into one by appending them together. The final step is loading the data back into Excel. In this step, we are basically telling Power Query to load back the cleaned and transformed data back into the Excel workbook so we can use it for our analysis. There are a few load options available. Loading as connection means that the data will not show on any of the worksheet of the Excel workbook, but it will stay in the Power Query's memory. Loading as pivot table creates a pivot table directly from the clean dataset. In our example, we loaded the 3 source tables as connections, and for the final consolidated table, we loaded it as a pivot table. Other load options include loading as an Excel table or as a pivot chart, but for this course, we're mostly going to use connections or pivot tables. In the next few videos, we will explore other features of Power Query. We will connect to external data and apply more cleaning and transformation steps. For the next exercise, we will use a second file called raw transactions. Let's open it to get an overview. We have a dataset with 5 columns. We will import this data into Power Query and apply some cleaning steps. As discussed, this time we will use Power Query to connect to an external data that is outside of the workbook in which we are working with the Power Query. So I'm first going to close this file, and I'll set up a new workbook over here. And in this workbook, I will connect the Power Query to the transactions file. I'll go to the data, get data from file and from Excel workbook. Next, I need to provide location of the path where the file is saved, and then I will click import. Then click on transform data. And now the data has been imported into the Power Query editor. We can see the same 5 columns which we saw in the original file. Let's get some overview of the Power Query editor window. The pane on the left shows the list of queries. For now, we have only one active query. As we add more, they will appear over here. The ribbon on the top is where we will find different functions and cleaning features. From here, you can add new columns, transform the existing ones, delete rows or columns, etc. We will work through these functions shortly. On the right, we first have the query name. If we want, we can change the query name. Below that, we have an area for applied steps. And this is an important one because we'll be using it quite often. Whatever steps we perform in Power Query, they get recorded here in the form of an algorithm. In the center below the ribbon, we have a formula bar, which shows the code that is getting applied at each and every step. So let's study these steps briefly. In the first step, Power Query is connecting to the source data. If I click on this step, then the formula bar at the top shows the detail of what's happening in that step. And if we look closely, we can see that there is some code, and then we have the folder path which we just provided to Power Query. This is the folder path from which the query is getting the data. If we want to change the folder path, we can do it directly here. In the next step, Power Query is promoting the first row or the first record of the data set as headers. Now you might wonder, we never added this step, so how did it come through? These are some basic steps that Power Query Editor adds by itself by default. The third step is change data type. This is also an automatic transformation that Power Query has added. Power Query is looking through the nature of the data in each column and assigning a data type based on that. So for example, the column for the department name has been assigned the text data type. For the date column, it's assigning the date data type. We can also see which data type has been assigned by looking at the square box next to the column header. If we are not happy with any of the data type assigned by default, we can change it. Here, for example, the amount column has been assigned the text data type, and I want to make it number. So I'm going to go to the square box next to the column header, click on it, and then I can select the data type that I want to be assigned. In this case, I'll select decimal number. Now let's say I change my mind and I want to go back to the text data type. Unfortunately, in Power Query, there is no undo or Control-Z option like we have in the rest of the Excel. So we have to do it manually. I can either again click on the data type box and select text from here, or if I want, I can just go into the code and change it there. If you want to see the code for all the steps that have been applied so far in one place, you can view that by opening the Advanced Editor. As we can see, here the first step is the source step, in which Power Query is connecting to the folder path, which is mentioned over here. The second step is promoted headers, where it is taking the first row of the data set and using it as a header. And the third one is the change type step. In this step, it is taking each and every column of our data set and assigning the data type, which is mentioned here. Now that we have some basic understanding of the Power Query Editor, let's go ahead and do some transformations. First of all, in the amount column, I see we have some blank fields. I want to get rid of them. So I'll go to the drop-down and I'll filter out the blank fields. Next, in the account column, I see that we have a value called R&D. I want to rename it to Research and Development. So I'm going to right-click on the account column and then select Replace Values. I'll type the value that I want the system to find, and then the value with which I want it to be replaced. Also, I want to add a column which shows the name of the month to which the transaction relates. So for that, I have the date column here, and based on this date column, I can extract the name of the month. I'll select the date column, then go to the Add Column tab, select date, month, and I'll select the name of the month. Also, in the amount column, we have a value for an A. I want to get rid of that as well. And finally, I want to change the data type of amount column to numeric value, or I'll select decimal number in this case. While we were doing these transformations, you might have noticed that a new step was getting added in the Applied Steps section with every transformation that we did. These steps are hard-coded. For example, we first filtered the rows, so we can see that we have filtered the amount column for blank fields. Then we replaced R&D with research and development. Then we inserted the name of the month based on the date. Then we filtered the amount column for the NA values. And lastly, we changed the type of the amount column to number. These steps are saved as a part of the query. Every time we refresh, for example, when the raw data changes or when the new data is added to the raw transactions file, PowerQuery automatically repeats the same set of steps to clean and transform the updated data. If you want to cancel any of the steps that we have added, we can do so by clicking the cross sign next to the step name. For example, let's delete the change type step which we added in the end, and it's gone away. If I want to add it back, I'll just add it back like we added before. If we want to cancel any of the steps from the middle of the query, we have to be careful because each step depends upon and follows on from the prior step. For example, let's take a look at the change type step, which is the third step in this query. Here we can see in the formula bar that this step is looking at each column name and assigning a particular data type to that column. For example, the column called transaction ID is getting assigned the text data type, then column called date is getting assigned date data type, account is text, department is text, and so on. These column names are coming from the previous step, which is called promoted headers. If we delete this step, the column names which were there before are no longer there. This means that the change type step will also not work because it's no longer able to find the columns called transaction ID, date, account, etc. And if one of the steps in the query fails, then entire query will break up. So we have to be very careful if deleting any steps from the middle. Now to fix this problem, I'm going to go to the source step, and here I'm going to add the promoted headers step manually. I'll go to the transform tab and select use first row as headers. Now we have the same column names back again. So the change type step and all the preceding steps will start working fine. Now we have done some transformations. We will do a few more as well. But for now, let's load this data into the Excel workbook as a pivot table. We'll go to the Home tab, then select Close and Load to, Pivot Table Report. I can put the pivot table on the existing worksheet in cell A1 and click on OK. Now we have the pivot table pane and we can summarize the data by department. In this video, we will learn a very important and commonly used transformation called merge queries. Let's continue from our last exercise. We connected PowerQuery to the raw dataset, loaded it as a pivot table, and over here we can see a summary of amounts by departments. Now suppose I want the summary by department manager instead of department names. If I look at the pivot table fields, there is no department manager field. And it's also not there in the raw dataset either, based on which this pivot table was created. But I do have a separate file that has the mapping of each department name to its department manager. Let's open this file, department map. And here I can see a dataset with the department name column and the name of the manager. What we can do in this situation is that we can load this mapping table as a new query and merge it with our original query to bring in the manager's name into the original dataset. This works very much like the VLOOKUP or lookup formula, which we covered earlier in Module 2. So let's go to the original file, which we created before. And here I'm going to connect powerquery to the mapping file. So I'll connect it to department mapping, import it, then transform the data. The Power Query editor window will open up. I'm just going to rename this query to department_mapping. I'll go to the sources step first and then use first row as headers. Then I'm going to select all the columns and click on detect data type. And the data type is correct. All of them are text, which is exactly how I want. Now I will go back to the raw data query, which we had built in the last exercise. And here I want to bring an additional column for the department manager name. We can say that we kind of want to do a lookup based on the department name and bring in the department manager name from the department mapping table. So in this query, I'll go to the Home tab, select Merge Queries. A new window opens up. We need to specify which query do we want to perform the merge with. So I'm going to select the department mapping query here. Next, we need to select the column from both the queries based on which we want to perform the merge. Speaking in reference to the VLOOKUP or the XLOOKUP formula, this is kind of defining the lookup value which we want to use. So in these two tables, the column which has the same values is the department name. So I'm going to select department from the first table as well as from the second table. There are different kind of merge options available here. The most commonly used and the one that we will be using a lot in this course is the left outer. So let's go with that. Basically, a left outer merge keeps all the rows from the first table and pulls in data from the second table only where there is a match based on the department name in this case. So we'll go ahead and do OK. Now, as you can see, a new column has been added. I will click on the button next to this column to expand it. Now we need to select which columns from the second table or the mapping table do we want to bring in into this first table. So here we want to bring in the region manager. So I'll click on that and I'll uncheck this option. And there we go. Now we have the region manager available in the original data set. Let's go ahead and load the query. I'll select close and load to. Now you might wonder why Power Query is asking again how we want to load the data. After all, we already loaded the data as a pivot table in the last exercise. So what's happening here is that Power Query is asking about the new query which we just added. That is the department mapping query. We do not need this query loaded onto any worksheet. The reason why we set up this query was to merge it with the raw transactions query so we can bring in the department manager names in the raw transaction table. So here I'm going to choose only create connection and click on OK. Now, if I go to the pivot table, I will have the region manager field available. So I can remove the department name and bring in the region manager. Merge queries is quite a useful feature, but it must be used with caution. If there are duplicates in the mapping table or the lookup table, let's say, it can make your results inaccurate. To understand this further, let's look into briefly how the merge query works behind the scenes. Let's open the raw data query. You might have noticed that when we perform the merge, two new steps got added in the Apply the Steps section. The first step is the merge queries. In this step, we can see that Power Query is merging the raw data query with the department mapping query based on the department name column. As a result of this step, a new column has been added which contains the table, and that table is coming from the department mapping. And in the next step, we have expanded that table and brought in only the region manager field from the department mapping table. Let's go back to an earlier step, and this time let's only work with the first row which has transaction 001. It relates to the West region. After we did the merge queries, a new column got added for transaction 1, which contains the region manager name, and the region manager for transaction 1 is Diana. And where is the name for Diana coming from? If we go to the department mapping table, here we can see that for the West region, the region manager is Diana. So that is being brought up in the raw data query. Now the question is, what will happen if there were 2 records for West department in this mapping table. Let's try it out. I'll go to the department mapping file and I'll add one more row over there. First of all, I'm going to close it up, and then next I will open the department mapping file. And here I will add one more row for West department. And just to differentiate, I will give a new name for region manager. I'll save this file and close it. Now, if I go to the department mapping query, it is still showing only 4 rows because the data has not been refreshed yet. And if I go to the raw data, transaction 1 is only appearing once because in the department mapping table, there was only 1 record for the West region. Now, if I go to the department mapping table, refresh it, we have 2 records for the West region. If I go back to the raw data table, you will notice that the transaction 1 has been repeated twice. In the first row, it is picking up Diana as the region manager, and in the second row, it is picking up Andy. This is where the merge queries is different from the lookup function. We learned in the lookup function video that if there are duplicate values in the lookup table, the lookup formula is only going to bring in the first value that it encounters. The merge queries, on the other hand, will bring in both the values and create duplicate records. And in this situation, your total for the amount column can become inaccurate because it has duplicated amounts. So for example, for transaction 1, you can see the 841 is appearing twice. To solve this problem, and also as a good practice, you should always remove duplicates from the column of your mapping table, which is being used as the basis of the merge. So I'm going to go to the department mapping, and in the department column, because this is the column that is being used for the merge, I'll right click and remove duplicates. Now, our department mapping table has only 1 record for each department. If I go back to the raw data, all the transactions are now appearing only once. Within the same query, we can also perform multiple merges as well. I have another mapping file here, which contains the mapping of the account name with the type of account and the reporting group. Let's say I want to bring in these 2 columns as well in my pivot table. Like before, we first need to bring in the chart of account dataset into the Power Query editor. Last time, we used the Get Data button over here at the top to bring in the department mapping table. This time, we will use a slightly different approach. Let's open the Power Query editor. Here, as a first step, I will create a duplicate of the department mapping query. I will rename it as chart of account mapping. And then in the source step of the chart of account mapping query, I will provide the file path for the chart of accounts file. The file path is the same because both the department mapping file as well as the chart of accounts file are in the same folder. So I'm just going to go and change the name of the file towards the end. I will remove all the other steps. Now the chart of account dataset has been loaded as a new query. Now we can go ahead and merge it with the raw data query like we did before. Maybe one step that I would like to add is remove duplicates, although there are no duplicates, but it's always a good practice to have this step just in case in future if a duplicate comes up. Now I'll go to the raw data, select merge queries. This time the lookup column is the account and the lookup table is the chart of accounts mapping. And we have account column here as well. I'll keep the left outer, click on OK, and then I'm going to expand both the columns that I want to bring in, that is account type and reporting group. Notice that there are few nulls, and this is because Power Query is unable to find research and development account in the chart of accounts mapping table. Let's go there. And here we notice that the name of the account is R&D. So we can actually replace values. Instead of R&D, I will write research and development. Hopefully it should work now. Close and load to. Again, this prompt is about the chart of account mapping query because that's the new one that we have loaded. And we want to also just load it as a connection. We don't want that data anywhere on the Excel workbook. So I'll click on OK. Now in the pivot table, I will have the account type as well as the reporting group fields available. Great thing about Power Query, which I already mentioned before, is that it automatically updates the results when the new data is available. Let's assume in this example that Bob has resigned and we have a new manager, Dan, replacing him. I will open the department mapping file and I'll replace Bob with Dan. I'll save the file, close it. Now, if I refresh this pivot table, we will have the updated results. Same applies to other files that are connected via the Power Query. Let's say we have some new transactions in our transaction dataset. I'm just going to pick up some transactions from the bottom and paste them here. Save the file. Now, if I refresh this pivot table, you will see that the number gets updated. Next, we're going to look at a powerful transformation about unpivoting columns. But before we do that, it's important to understand the concept of data structure. I have two tables here. Both these tables have exactly the same underlying data. For example, if I sum up all the amounts in these two tables, I will get exactly the same number, which shows that the underlying data between these two tables is exactly the same. However, these tables look quite different. In the first one, the months are arranged across columns with each column showing the sales for that month. In the second table, the months are listed in one column and the sales values are in a separate other column. For the purpose of this course, we're going to refer to the structure on the left as the white table structure because it has more columns and less rows. For the one on the right, we're going to refer to it as a vertical table structure or taller structure because it has lesser columns and more rows. When working with Power Query or data analytics in general, you should always organize your data in a vertical structure. This can make your queries more efficient. It can also improve the processing speed, especially if you're dealing with large data sets. And furthermore, it is also helpful in building measures in DAX, which we're going to learn about in the upcoming lessons. So how do you decide if your data has been structured appropriately or if there is a further room for verticalization? When structuring your tables, you should ensure that each column of your table contains a unique nature of data. If multiple columns in your table have the same nature of data, this means that you can further verticalize your data structure. Let's work with an example. Here, I have a small data set with columns for product name, region name, and then I have 3 columns for Jan, Feb, and March. Each of these columns show the same exact thing, that is the sales values. Since these 3 columns have the same nature of data, it indicates that there is a room for improvement and we can verticalize this table. Rather than splitting them across 3 columns, we can create one column for the month name and another column for the sales values. The revised verticalized table will look something like this. In the next exercise, we will convert a dataset from wide structure to a vertical structure using Power Query's unpivot feature. The file we will use for this exercise is called budget-wide. Let's open it. As you can see, the dataset in this file is clearly in a wide format, and we must verticalize it. So I will close this file. I will go to the original Power Query practice file where we had built a few queries. I will connect the Power Query to budget-wide file and import the dataset. I'll remove the steps which Power Query had added by default. So now we have the dataset in its original form. There are a few extra rows in this dataset. We do not need these rows, so I'm going to remove them. I'll select Remove Top Rows. And I'll remove the top 4 rows. I can promote the first row as header. Next step is to convert this data from wide into a vertical format. The columns I want to verticalize in this data set are January to June columns, because the other 2 columns, that is category and subcategory, contain unique nature of data. The category column contains the category descriptions and the subcategory contains the subcategory values. But from January to June columns, all the columns contain sales values, that is the same nature of data. So to verticalize, I will select the category and subcategory columns, then right-click and select the option to unpivot other columns. Now we have one column which talks about the month name, so I can rename it, and the other column which has the values. So that's how, by using the unpivot feature of Power Query, you can convert datasets from wide into a vertical structure. Note that when we were discussing about how to decide if the structure of the data is fine or it needs further improvement, we said that each column of your table should have a unique nature of data. Here, we are talking about the nature of the data and not the data type. Your table can have different columns with the same data type. For example, here, the category column, subcategory column, the month name column, they all have the same data type, which is text. But they are talking about different things. The category column contains the names of the categories, the subcategory has subcategory names, and the month name column is talking about the names of the month. The data type of these columns is same. However, the content inside these columns is different from each other. Many times you might have to work with raw data which is arranged in such a format where each column has multiple headers. This is often the case when you extract data from companies' ERP or reporting systems. In this video, we're going to see how we can transform these kinds of dataset into a proper structure using Power Query. The file name for this exercise is multi-header table. Let's connect Power Query to this file. There are 2 sheets in this file. I'm first going to take the January sheet and transform it. Like before, I'm going to cancel the default change type step which Power Query had added. First of all, I want to remove row number 5 because it's empty. If you go to the default options, you will see there are options to delete the rows from the top or from the bottom. So to deal with this kind of situation, one commonly used technique is to add an index column and then filter out the rows which you don't want. So I'm going to add a column, index column. I'll add it from 1. So now our index column indicates the row numbers. I will filter out whichever row I do not need. So I'm going to uncheck on 5. And there we go. That particular row with null in it has disappeared. Now I can delete the index column because we will not need it. To arrange this data in a vertical format, we'll need to perform 3 steps. In the first step, we will transpose the entire table. So I'll go to the Transform tab and select Transpose. In the second step, we will promote all the headers. No need to change the type at this stage. And then we're going to select the 4 columns which came up as a result of the transpose step. I will unpivot all the other columns. Now I can rename this column which came up as a result of unpivoting. We will call it, let's say, P&L line. And now I can select all the columns and click on Detect Data Type. Sometimes you might want to change the data types which Power Query has assigned by default. So for example, here, I'll convert it to text and click on Replace Current. The rest of the data types look okay. So now we have transformed the original data set, which was in a wide structure and also had multiple column headers. We have cleaned it up and brought it into a vertical structure. If you recall, we had another sheet in this file for the month of February. Let's say we want to bring in the February data set in the same structure in Power Query. Since the raw data on the file is arranged in exactly the same way for both the January as well as the February sheets, we can apply the same steps to the February dataset which we have developed here for the January dataset query. So as a shortcut, I can first create a copy of the January query, rename it to February. Now all the steps from the January query are already here, and all I need to do is change the source of data. In fact, the source will also be the same because it's in the same Excel file. We will just need to change the name of the sheet from where the query is picking up the data. So I'll go to the navigation step. Currently, it's picking up the data from raw data Jan sheet. I'm going to change it to Feb, and then all the other steps will apply as normal. Next, we're going to learn about appending queries. It's another very important and commonly used feature. Here, we have two queries which we developed in our last lesson. One contains the January data and another one has the February data. Let's say we want to create one query that contains data for both the months in one place. This is important because ultimately, when we will load it to a pivot table, we will want one pivot table that has all the data in one place rather than separate pivot tables for each month. To combine two queries into one, we can use the append feature in Power Query. Go to any one of the query. Let's say I'll go to the January query. Then go to the Home tab and select Append Queries. Here we've got two options, Append Queries and Append Queries as New. If we want to combine the February data right at the bottom of the January data, then we can use the Append Queries option. If we want to create a new query that has the combined data, then we can go with the Append Queries as New option. I'll show you both of them. So first, let's select Append Queries, and the table that we want to append to the currently selected table, which is January table, is raw data February. We'll click on OK. Now, if I scroll down, I can see that February data has been combined within the January query. Alternatively, if we want to create a new query with the data for both the months in one place, we can use the Append Queries as New option. Here, a new query has been created, which is called Append 1. I will call it Consolidated. And this one has the data from both the other queries, that is raw data Jan and raw data Feb. Also, notice the syntax that is being applied in the source step of the new consolidated query. It's basically combining the data from the two tables, raw data Jan and raw data Feb. If we want to append a third table in, we can just put in a comma and then the name of the third table, and the data from that table will also flow in. Alternatively, if I want to remove one of the tables, let's say I want to get rid of the data from the table raw data Jan, I just need the Feb data. I'll remove it, press enter, and now the consolidated query will not have the data from raw data Jan any longer. If I want to go back, I'll just click in the formula bar, press Ctrl Z, and then enter. Now we are back to the previous position. There are a couple of watch-outs to look after when you are appending queries. To combine the tables properly, the column names of the tables you are appending should be the same. If the column names are different, Power Query will create new extra columns in the combined query. Let's understand with an example. I'll go to the raw data Jan query, and here, For the month name column, I will rename it as period. In the Feb query, the column name is still month. Now, if we go to the consolidated table, we will have both the columns, a column for period as well as for month. For the January dataset, we will have data in the period column. And if we go down, then in the February dataset, we will have the data in the month column and period will be empty. This is not the most ideal combination, so always ensure to have consistent column namings across the tables that you're appending. In this exercise, we're going to learn about how to connect Power Query to a folder and retrieve data from all the files that are inside of that folder. I've got one folder here, and inside that folder, I have 3 files. Each of the files contains transactions-related data for a particular month. For example, the first file has January data, the second one is February, and the third one has March. Let's open one of the files. Each file has the same exact structure. It has got 5 columns: date, transaction ID, account department, and the amount. Now I want to apply certain transformation steps to each one of these files and then combine them into one dataset by appending them together like we did in the last video. Instead of connecting to each file separately, I can connect Power Query to this folder so that it automatically picks up all the files that are inside of this folder. This is especially useful when you receive new files every month and the files are in consistent format and you need to combine the results in one place in one pivot table, for example, for your analysis. So I'll set up a new Excel workbook. Go to the Data tab, Get Data, and this time I'm going to select From Folder. I'm going to give the location of the path where the folder is saved and then select the folder which I want to connect to. A window opens up which shows me the details of all the files that are inside the selected folder. I'm going to go ahead and select Combine and Transform. As I mentioned, before combining the data, we want Power Query to apply few transformation steps to each of the files. To do this, Power Query uses a sample file. We define steps on this sample file, and then the same steps are then applied to all the files in this folder. You can choose a specific sample file from the drop-down over here, or simply go with the default option, which is the first file in the folder. I'll go with the default, click on OK. Now the Power Query editor window will open up, and this time Power Query has added a few more queries than what we saw in our previous exercises. We won't go through the details of each of the query, but here are the basics. The first query is the sample file query. This query basically brings in the first file in the folder because we designated it as a sample file. The next 2 queries are a couple of helper queries, and we don't need to worry about them or change anything in them at all. The next query after that is the transform sample file query, and this is an important one. Here we need to define all the transformation steps that we want Power Query to apply before it appends and combines the data from different files. For now, this query has only one step, which is promoted headers. And let's assume we are fine with it and we don't need any other transformations for now. Now Power Query is going to take each and every file from the selected folder, apply these steps which we have defined here in the transform sample file query, and then append the resultant data into one consolidated query. And that consolidated query is over here, which is called folder combine. For our understanding, let's do a quick inspection of this consolidated query as well. In the first step, the query is connecting to the source folder, and we can see the names of each of the files that are inside of that folder. In the next step, the query is checking if there are any hidden files, and then in the third step, which is an important one, the query is applying a function to each of the files that are inside of this folder. And what is the name of that function? The name of that function is transform file. And this function contains all the transformation steps which we have defined in the transform sample file query. If I scroll to the right, you will see that as a result of that function, a new table is produced, and that table is stored as a value in this new column that has been added here, which is called transform file. In the next step, it's renaming one of the columns. It renamed this column from name to source name. And in the next step, it's removing all the unnecessary columns. Now only 2 columns are left, the name of the file and the transform file column, which contains the tables that were produced as a result of the application of all the transformation steps that are there in the transform sample file query. After that, the query is expanding those tables, and in the end, it is assigning data type to each of the columns. If I click on the filter on the source name, you can see that the data from all the 3 files has been consolidated here. I will just remove the change type step, which is towards the end, because it can sometimes cause error. Now let's say I want to add a couple of other transformations. So I'll go to the transform sample file query. Here I'm going to remove the account column. And let's say I want to rename the department to region. When I will come back to the folder combine query, you will see that those new transformation steps have taken effect over here as well, and they have been applied to all the files in the folder. Now we can load this data as a pivot table. I'll bring in the source name here and the amount in the values section. Now let's say I have received the transaction file for the next month, and I want to combine the data from that transaction file into this pivot table. I'll go to my source folder, and over there, I'm just going to drop in the file for the next month. Now, if I come back to my pivot table and refresh it, you will see that the data from the next file is also flowing through automatically. Over the next few lessons, we're going to learn about Power Pivot and DAX language. Power Pivot is an Excel feature that lets you work with large datasets like a database. You can build data models, set up the relationships between different databases, and perform various different kinds of analysis. DAX is the formula language used to create calculations within those Power Pivot models. Before diving into details, let's start with an example that will help us understand where and why we would want to use Power Pivot or DAX. Let's assume we are working with this dataset. It has several columns. The important ones are the account. Here we have the account names to which the amounts relate. Then we have the scenario column. Inside scenario column, we have 2 scenarios, actuals and budget. And then we have the amount column. Using this dataset, I want to create a summary table which looks something like this. I want the accounts on the rows, and then I need 2 scenarios over the columns, actual and budget. I need amount in the body of the table. And in addition to the 2 scenarios, I want to have the 3rd column, which is the variance, which shows the difference between the actuals and the budget. Now you might have thought that we can achieve this result via pivot table, which we learned about in a previous lesson. So let's go ahead and try it out. I'll select the entire table, insert pivot table, and I'll add it to a new worksheet. I'll bring in the account in the rows, scenario in the columns, amount in the values field, and I'll remove the grand total. We've almost got there, but one column is still missing, and that is the variance column, which calculates the difference between actual numbers and the budget numbers. If you recall the lesson on pivot table, we learned about calculated field. Can we use that here? Let's go ahead and try. I'll go to pivot table analyze and then select calculated field. I want to calculate the difference between the actual amount and the budget amount, but I do not see the actual or the budget fields over here. This is because calculated field creates a new field or a new value in your pivot table by performing a calculation on one of the existing fields of your pivot table. Actual and budget are not existing fields in our pivot table. We have just one field for scenario name, and inside that scenario name column, we have actual and budget as 2 separate dimensions. So the calculated field option will not do the job for us over here. To solve this problem, we can use Power Pivot to load our data into a database and then use the DAX language to perform calculations on that database. So I'm going to close this one and I'll delete the sheet 1 where we created the pivot table. Now we are back to our raw data set. To bring this data set into Power Pivot model, we will need to do a couple of quick steps. First of all, we need to load this data set into the Power Query editor. I'll convert this data set into an official table, and then I'm going to load it into Power Query. Let's call it raw data. The transformations look fine. Now we're going to load it as a pivot table. I'll put it on a new worksheet. And I'm also going to check this option which says add this data to data model. Now click on OK. Now the pivot table has been set up and we can use the fields on the right to create the pivot table as per usual. However, the Power Pivot has not been activated yet. To activate the Power Pivot, I'll go to File, Options, Add-ins. Then I'll select the COM add-ins, and over here, I'm going to put a check against Microsoft Power Pivot for Excel. Click on OK, and after that you will see Power Pivot tab will appear on the top. When you click on the Power Pivot tab, you will see a few options here. The first one is the Manage or the Manage Data Model. Let's click on it. This button will open up the database which is inside of our Power Pivot model. So here you can see that the raw data set which we had imported via Power Query is appearing here now as a database. On this database, we can perform any calculations using the DAX language. For now, our Power Pivot model has only one table, but if we load more tables into the data model, they will appear here as well. Let's keep this view of the database in mind. Later on, when we will be setting up the calculations using DAX, having the structure of the database in mind will be very useful. Now I'm going to close this window. Next, we're going to set up measures using the DAX language. A measure is a calculation that runs on your data model or your database. It's typically used to summarize or aggregate the values. Let me explain this a bit further. We know that in our final pivot table, we want to show a variance number. And that number is not there in our original dataset, as we can see from the pivot table fields as well. One option could be to add a variance column in the original source data, but that will make our database larger and more complex. Furthermore, in this example, we're only talking about one variance column. In real scenarios, we might want to add many other calculated columns that might not be part of the original dataset. And creating a separate column for each of them either in the Power Query editor or in the original source data can make your dataset heavy and complex. And that is where the concept of measure comes in. A measure lets you create calculations without changing the structure of your database. That way, the data model stays clean and you still get the results that you're looking for. Think of a measure as a virtual calculation that runs only when you need it, instead of being stored in your database forever. To set up a measure, you can click on the Measure button and select New Measure. A new window will open up where we need to define the calculation for this measure using the DAX language. We're going to start with a very basic calculation, a simple sum of the amount column in our database. First, we have to choose the table where the measure is going to be stored. In this case, we have only one table, which is called raw data, so I'll keep the measure there. Next, we have to give our measure a name. I'll call it amount total. Finally, there's an option to add a description. You can put some notes here. In advanced models, you might have lots of measures, and sometimes the names of the measures might also start looking alike. So you can put some notes here to keep things organized. In the next field over here, we need to define the DAX formula. Just a very quick heads up over here. DAX language is a broad topic on its own. In fact, there are many full courses dedicated just to the DAX language. In this course, we won't go into the full depth of the language. Instead, we'll focus on some of the key basics, which will be enough to give you a solid understanding of the concepts that you will need to apply when we start building the models in part 2 of this course. So to have the total of the amount column, we're going to use a very simple formula, which is called sum. And inside this formula, we need to provide the name of the column which we want to sum. So the name of the column is amount. We can also select this one as well. This notation is more descriptive. It has the table name first, the raw data, which is followed by the column name inside the square brackets. Using the full notation is better because let's say if you have many tables and several of the tables have amount column, then having the full description will be useful because it will show you which amount column and from which table is the measure summing up. So I'll select raw data and amount. Then I'll close the bracket. I'll select the formatting of this measure as number with 1 decimal place and 1000 separator and click on OK. Now the new measure appears up in your pivot table fields. You can use it anywhere in your pivot table. So let's say if I create a pivot table with account in the rows and amount total measure in the values, it will work as expected. To have our desired pivot table output, we need to set up 3 measures. First measure that shows the actual amount, second one for the budget amount, and the third measure for the variance. Let's go ahead and start setting up the measure for actuals. To have the actuals number, we will need to sum up the amount column, like we did in the last measure. However, we don't want to sum up the entire amount column. We only want to sum up those rows of the amount column where the scenario is equal to actuals. Think of it like applying a sum-if logic, which we learned earlier in the course. In DAX, we can do that using a function called calculate. So I'm going to type in calculate. The calculate function has 2 arguments. The first one is the expression. Here, we have to define what operation we want the function to perform. So as we said earlier, we want the function to sum up the amount column. The second argument is the filter context. So it's kind of a condition under which we want the function to perform the sum. Here, I'm going to say that perform the sum where scenario equals to actuals. So I'm going to write in raw data scenario equal inside quotation mark actuals. Let's check if the formula is correct. There are no errors in the formula. I want to format this measure as a decimal number with the 1000 separator and click on OK. Now we have the actuals number in here as well. Following the same logic, we're now going to set up the budget measure. Again, I will sum up the amount column when scenario is equal to budget. The formula is correct. We'll put it in a number format with a 1000 separator, and now we have the budget. This example also nicely shows you the difference between the first measure which we created, that is the amount total, and the other 2 measures which we just set up. The amount total measure is summing up the entire amount column, irrespective of which scenario does the amount relate to. The actuals is only summing up the amount where the scenario is actuals, and budget is taking totals only for the budget scenario. And the sum of budget and actuals will tie to the total amount. Next, we're going to set up the measure for variance because that's the last measure that we need to complete our pivot table. This one is going to be simple. Here, I'm just going to take the difference between the actuals measure and the budget measure. Once a measure is created, you can use it inside other measures formulas. For example, here we are calculating variance by taking the difference of the actuals measure and the budget measure. And a sigma or summation sign before the name indicates that here we are talking about a measure and not any column of the table. So I'm going to select that. Check the formula, it looks okay. Again, formatted as number and 1000 separator. Click on OK. Now we have the variance measure as well in our pivot table fields. I'll click on OK. We do not need the amount total, so I'm gonna remove that and I'll just resort the accounts. And there we go. We have our desired table. Well done everyone on completing part 1 of this course. So far, you've built a strong foundation. You've learned how to work confidently with Excel formulas, explored powerful data tools, and even started using automation through powerquery, PowerPivot, and DAX. These aren't just Excel features. They're the building blocks of how modern FP&A teams manage and analyze their data. Now you know how to structure, clean, and connect information in a way that sets you up for real analytical work. So in part 2, we're going to start putting these skills into action. See you there. Welcome to Module 5. One of the core responsibilities of FP&A is to consolidate information from across the business, bringing together results from multiple entities into one clear financial picture. In large organizations, there are often several business units, markets, or geographies, each with its own finance controller. But those controllers focus mainly on their own unit's performance. They do not extend beyond that. But investors and senior management aren't interested in fragmented views. They want to see the one big picture, how the entire group or holding company or how their overall investment is performing as one business. That's why every organization needs a central finance team that can collect, align, and consolidate data from different entities, ensuring a structure and coherence. And that's where FP&A comes in. However, consolidation isn't just as simple as adding up the P&Ls. There are some complexities. Entities may be in different countries, so they might have their financials in different currencies. They might follow different reporting structures or use slightly different accounting setups. Some might even have unique ways of categorizing revenue and expenses. So your job in FP&A is to bring all of that together in a consistent, comparable format that the management can trust. And because it's going to be a repetitive process, it needs to be done in a smart and automated way. Ultimately, FP&A acts as a bridge between individual business units who focus on their individual financials and the corporate leadership who wants to see one consolidated picture. So as FP&A teams, we need to turn this scattered financial data into one cohesive story that supports decision-making and performance review. In this module, we're going to start building that bridge, learning how to consolidate data from multiple entities, handle currency translations, and this will lay the foundation for more advanced analysis in the upcoming modules. All right, let's get started. Before we start consolidating the P&Ls, let's quickly align on what does a P&L, that is a profit and loss statement, actually show. I know many of you might already have finance background and you would already know what does a P&L mean, but for anyone new to this or who is not from a finance domain, the short refresher will help set the context. A profit and loss statement, also called the income statement, summarizes a company's revenues, costs, and expenses over a specific period to show its profitability. The usual structure of the P&L is as follows. At the top, we have the revenue line. This is the amount that company earns by selling its products or services. After that, we have cost of sales. This is the amount that company spends to produce or deliver the goods or services that it has sold. The difference of these two gives us the gross profit. Next, we have the operating expenses, things like salaries, rent, marketing, etc., which lead to operating profit number, also called EBIT, earnings before income and tax. Sometimes you might even see lines for interest and tax expenses. Deducting these expenses, we reach to the bottom line, which is also called net income or net earnings. In real-world FP&A, you often deal with multiple entities. For example, one entity would be based in United States, another one in Canada, third one in Australia, and each of them will be maintaining their own P&L. Consolidating the P&Ls of these different entities allows management to see the group level performance, compare regions, and prepare meaningful reports. We'll start off by learning how to consolidate P&Ls when all the entities are reporting in one common currency. Let's say, for example, different business units who are all reporting their P&Ls in US dollars. Once we have mastered that, we'll move on to a slightly more complex case, that is consolidating the P&Ls of different entities who are reporting in different currencies. Here we will apply exchange rates and calculate the consolidated totals in a base currency. In this video, we're going to prepare a consolidated P&L for the entire group based on the P&Ls of 3 individual entities. I have 3 P&Ls over here. Let's go ahead and open the first one. We have a P&L by month in a pretty standard format. The files of the other two entities are also in the same structure. To prepare a consolidated P&L based on these individual P&Ls, there are two broad approaches. The first approach is the manual one. This relies on Excel's traditional formulas. The second one is slightly more automated and it relies on powerquery. Let's go ahead and consolidate using the first approach. So I'm going to set up a new Excel file here. In this file, first of all, I'm going to bring in the same exact structure which we have in the individual entity files. Next, I'm going to link each of the cells over here in the consolidated file to individual entity files and sum them up. To do that, I'll first of all open all the three entity files. So this is the entity 3 P&L. We've got entity 2 over here, and then we have entity 1. So here in the consolidated file, I'm going to give reference to the revenue for the month of January in entity 1, then a plus sign, then revenue for January from entity 2, and lastly, I'll add the entity 3. We have the totals here. I'm going to remove the absolute references because I'll want these formulas to move. Then I can copy and paste as formulas as well as formats. If I want, I can now close the other entity files. So I will close them one by one. So that was pretty much it. We have the consolidated P&L here. Note that this consolidated file is connected directly to the entity files. If you want to see the connections of this file, you can go to the Data tab and click on Workbook Links. This will show you that your consolidated file is connected to these three files. Later on, if there is a change in any one of the entity's numbers, you can update the values by clicking the refresh button from here. You can also refresh any one of the files by clicking the refresh button under the individual file name. Alternatively, if you open both the consolidated file and any of the other entity file at the same time, the numbers in the console file will update automatically. For example, I'm going to open the entity 1 file. The consolidated file is already open. Now, if I make any change in the entity 1 file, it will automatically reflect over here. I'll do Ctrl Z, close the file, and we'll be back to the original position. So our P&L is now consolidated, but this approach clearly has some drawbacks. For example, let's say I want to see the results only for entity 2, or maybe I want to see the results only for entity 2 and 3 combined, and I want to exclude entity 1 altogether. Or let's say, what if I only want to focus on the numbers for quarter 2 or quarter 3? Of course, in the current setup as well, I can address that. For example, to get the quarter 2 numbers, I can sum up April, May, and June numbers on the side over here. Or I can remove the links to entity 1 altogether to see the numbers only for entity 2 and 3 combined. But these steps are clearly time consuming and the approach will be quite inefficient. The problem is that this setup doesn't give us the flexibility to easily slice and dice the data. And in FP&A, these kind of requests will come up all the time. Analyzing numbers from different angles is a core part of the role. That's why we need a setup that makes the process smooth and dynamic. In the next lesson, we'll see how powerquery can help us consolidate the P&L in a way that overcomes these limitations. In this video, we will consolidate the 3 entity P&Ls using powerquery. I'll close this file, which we had set up in the last video. Now I will set up a new Excel file. I will connect this file to the entity 1 P&L via powerquery So I'll go to get data from Excel workbook. Since we've got only 3 entity files, I can connect to them one by one. But if we had more files or more entities, it would of course be better to keep all the files in a separate folder and then connect powerquery to that folder so it can pick up all the files from there. But since we have very few files here, I'll just connect them one by one. I'll first connect to entity 1. Next, we will do some transformations. First of all, I'm going to remove the 2 default steps which powerquery had added, which is change type and promoted headers. We do not need the last 2 rows, so I'm going to go to remove rows, remove bottom rows, and then select 2. Also, we do not need the column for total. In the pivot table, we will be able to calculate the totals ourselves, so I'm going to delete this column here. Next, I'm going to promote the headers. Also, as you might have guessed, the table is in a wide format. We want to convert it into a vertical table. So I'm going to select this column and unpivot other columns. This new column will become the month, and then we have the value column. I'll rename this query as entity 1. Lastly, I will set up a column for entity name. Go to add column, custom column, entity name. And for this table, we will put the name of entity 1 and format it as a text value. Later on, this column will be useful for slicing and dicing the data in the consolidated pivot table. Now we need to bring in the data for entity 2 and entity 3 as well. To do that, I will create a copy of the entity 1 query, rename it as entity 2, and inside of it, I will just change the source step and give reference to the entity 2 file. So entity 2 file is also saved on the same location, only the name of the file is different. I'm going to name it as entity 2. And also in the last step where we added the entity name column, here I'm going to put it as entity 2 for this one. Next, I'm going to create another copy of this, rename it as entity 3. In the source step, we will give reference to entity 3 file, and in the added custom step, we're also going to give the name of entity 3. The data from all the 3 entities is here in the powerquery editor. Now we need to combine them together so that we can load it as one pivot table. With any query, I'll go to append queries, append queries as new. We need to combine 3 or more tables, so I'll select that option. We'll go with entity 1, 2, and 3. Click on OK. The new query has been set up. I'll call it console. Now we can load all of them. Initially, I will load them as a connection. And the only entity we want to be loaded as a pivot table is this one. So I'm going to right click, load to pivot table report over here. Now I can create the pivot table as per usual. I'll drag the account in the rows section, month in the columns, value in the values section. Also, I can resort the accounts as per the standard structure of the P&L. I can remove the grand total because the net income is already doing that for us. And I can format the numbers as I like. Now, if I want to see the results only for entity 1, entity 2, or combined of entity 2 and 3, I can do that by adding a slicer. So if I select entity 2, it will only give me the entity 2 numbers. I can combine 2 and 3, or I can play around as I want. Now let's say I want to see the P&L or slice the P&L by quarters rather than by month. We can do that as well by setting up a small mapping table between the month names and the quarter names. It will be a one-time effort, but it will help in slicing and dicing the data in the long run. So I'll go to this, I'll open a new sheet, put calendar mapping, and here I'm going to bring in the mapping table. It has the names of the months, the quarters, and I've also included the halves. We're going to load this table into the Power Query. call it month mapping. The transformations are looking okay. And in the consolidated query, I need to bring in a column which shows the quarter names as well as a column that shows the half names. So I'm going to merge the console query with the month mapping query based on the month name. So I'm going to merge queries. From the first query, I'll select the month column. The second query with which I want to do the merge is month mapping. And again, the column will be the month column. I will expand this column to bring in the month and the half columns from the mapping table. We'll press close and load to. We'll only create the connection. This time it's asking about how do we want to load the month mapping query, and we can load it as a connection. The console query is already loaded as a pivot table. So I'll click on OK. Now I'll go to my sheet 1 where we have the consolidated table. And in the pivot table, we can see we have the fields for quarter and halves as well. So instead of seeing the P&L by month, if I want to see it by quarter, I'll just drag it over here. Or let's say I can keep month in the columns and I can add quarter as a slicer. So if I want to see the P&L only for quarter 2, I'm going to select that, quarter 3, quarter 4. So that is how setting up a consolidation using Power Query can help you slice and dice your data from different angles, and this can be super helpful for your analysis work. However, when using Power Query, errors can happen and they might as well go unnoticed, so you have to be very careful. One of the most common sources of errors is the inconsistent line items naming across various entity files, which are being consolidated. What this means is that if the names of the accounts, for example, in your different entity files are not the same, it can corrupt your final pivot table, or it can sometimes even lead to errors as well. Let me show you by an example. I'll go to the entity 1 file. And instead of revenue, I will call it sales amount. And let's say in the entity 2 file, instead of COGS, I will put it cost of goods sold. So the naming of the accounts is now inconsistent. Now, if I refresh the pivot table, you will see that the amounts in the revenue and the COGS line have gone down. This is because new accounts have been added up at the bottom. So this kind of damages the structure of your pivot table which you had set up. And not just the structure of your pivot table, sometimes it can also render your analysis inaccurate. Let me show you an example. I will do Ctrl-Z to go back to the original state. And let's say now we are analyzing only the revenue account. So I'm going to put a filter on the revenue field. Now, if I refresh the pivot table, you will see that the revenue number drops down because there is no revenue account in the entity 1 file. We changed the name of this account to sales amount. And although the sales amount line in the entity 1 file is still talking about the revenue, but it is not flowing here in the consolidated P&L. Because it's going to a new line called sales amount. And there's always a very good chance of these type of errors happening because many times you would not be setting up the individual entity files yourself because that might not be the role of the FP&A. You might be getting these files from finance leads of different entities. And since these finance leads will be different people for different entities and everyone has their own way of maintaining the files, naming inconsistencies are quite common. To fix this error, we first need to understand which entities have wrong account names in their files. We also need to know which account names are exactly inconsistent or are not in line with the standards, so we can go to the source file and fix the naming there. In this case, we know that it was entity 1 and entity 2 because we changed it ourselves, and we also know that the sales amount and the cost of goods sold are the inconsistent names. But this is a very small and simple dataset, so the problem is easy to spot. In real scenarios where you might have 50 accounts or multiple entities, it's not practical to catch these inconsistencies by eye every time you refresh the pivot table. So to solve this problem, I usually use a technique, and I'll walk you through it. First, we need to set up a table with a list of standard account names. So I'll open a new sheet. These are the standard account names that I expect to see in every entity's file. I'll convert this to a table, then I'll load this table into powerquery. Now in the console query, I will set up a merge with the account mapping table based on the account names. So I'll go to merge queries. From the first table, I'm going to select the account field. I'll merge it with the account mapping table, and I'll use the standard account name as the criteria for merge. And now I'm going to open the standard account name column. Whenever an account name in the entity file is inconsistent or does not match the standard name defined in the account mapping table, this column over here is going to return a null. For example, if I scroll down, I will see that for the account called sales amount, the standard account name has returned a null. This is because in our account mapping table, there is no such thing as sales amount, we just have revenue. Likewise, if I keep scrolling down, we can see that even for the cost of goods sold, it's returning a null because in the standard account naming, we have a short form called COGS. So next what I'm going to do is replace values, and wherever there is a null value, I'll replace it with check account name. Now we can load it into our model. Again, here it's asking about the load option for the account mapping table, which we just added right now. And we do not need to load this into the workbook, so I'll keep it as a connection only and click on OK. Now I'll go to my main pivot table and I'll create a copy of it on a separate sheet. I'll name this sheet as checks. Here, I do not need the values for different accounts, so I'll remove that. I also don't need the month. I just need the account name for now. And now I'll drag the standard account name field into the filters, and I'm only going to filter those accounts where we have check account name. So here it shows us that there are two inconsistent account names, and that is the sales amount and the cost of goods sold. If you want to know which entity they are coming from, I can add the entity name into the rows section right next to the account. And that will show us that the sales amount name is coming from entity 1 and the cost of goods sold is in entity 2. This is helpful because now we can go to these entity files and fix the naming there. To ensure it's working properly, let's test out this setup. This time I'm going to open the entity 3 file, and here I'm going to change the name of one of the accounts. I'll save the file, close it. Now, if I refresh the pivot table, you will see that a new account name appears. And on the checks sheet, I will see that this is an inconsistent account name and it's coming from entity 3. If I want to clean up the consolidation and remove all the errors, I can go to each one of these entity files and correct the account names there. So once I have spotted out the inconsistent names, I can go to each and every file. In the entity 1, I'll rename it to revenue. In entity 2, I will replace cost of goods sold with COGS because that's the standard name. And in entity 3, we will make the research and development into short form R&D. Now, if I refresh the main pivot table, hopefully the structure will be clean now. And also on the check sheet, we will see nothing, which means that all the account names are correct and consistent. With this approach, you don't have to deep dive into the data to check if there are any inconsistencies or errors. You will be able to spot out the errors just by looking at the check sheet. In the last exercise, we consolidated P&Ls of 3 different entities, and these 3 P&Ls were in the same currency, so the process was much simpler. In this exercise, we're going to consolidate P&Ls of 3 different currencies into one. I've got 3 different entities files here. The first entity is based in the United States, so it has a P&L in US dollars. Let's open it. This is the structure of the P&L. Instead of by months, we have it by quarter, and the accounts are more or less the same as we had in the last exercise. The second entity is based in Canada, so its P&L is in Canadian dollars. Again, it's in the same structure. And the third entity is based in Australia, and its P&L is in Australian dollars. In the last exercise, all the entities were in same currency, so we just took their amounts and summed them up. In this exercise, the currencies are different, so we cannot just simply sum up the numbers. We'll first need to convert each one of them into a common currency, and then we will be able to sum up the numbers. Which common currency you select will depend on your organization. Usually, this will be the currency of the country where the head office of your company is based. For example, if you work for a US multinational, you might want to consolidate everything in US dollars. For this example, we're going to assume we want to consolidate everything in US dollars. The first step of this exercise will be the same as we did in the last one. We will set up a new Excel file in which we will connect powerquery to each one of these entity files and then append the 3 queries together. So let's go ahead and do that. First, we're going to connect to the USD P&L. Like always, I'm going to remove the default change type step. There are a few columns which are not needed. Column 6, 7, and 12. Because these are totals columns, so we don't need it because in the Power Query, when we set up a pivot table, we are going to automatically get the totals. So I'm going to just delete them. The first row is partially empty, but it has the year name. So we will need to keep this row in there. The second row has the quarter names, so we will need that as well. So this is kind of a multi-header table, and we learned about it in a previous lesson. To transfer this dataset into a proper vertical format, we'll first need to transpose this table. Then I'm going to promote headers. Also, I see that in column 1, some of the rows are empty, so I'm just going to right-click, go to Fill, and Fill Down. We can rename this column as Year, and I'm going to provide it the text data type. Now we can unpivot all the columns except the first 2 ones. Also, I do not need this change type step here because I'm going to apply it towards the end of the query. And this one as well. Now we're going to add column for entity name. This is entity 1. And another column to store the currency of this entity. For entity 1, it's USD. I'll change the name of the query to entity 1. This looks good so far. Now we're going to bring in the data for entity 2 and entity 3, and we'll follow the same approach like we did in the previous exercise. I'm going to duplicate this 2 times. This one I will call entity 2. In the source, I will give the name of the entity 2 file. And in the new columns that we had added, we will update the values accordingly. This one is for entity 3. Next, we're going to combine these 3 queries by using the append queries feature. And now we're going to load it. First, we're going to load all the queries as connection. And in the next step, we're going to load the appended query or the consolidated query as a pivot table report. Apparently, something went wrong in the query setup because I see that in the account fields, it has the quarter names. So I'll go back to the query. Yeah, this should be quarter and this should be account. I'll do the same for all of them. The consolidated one also looks good now. Let's close and load. And let's refresh it. All right, this looks good. I'm going to fix the number format using the custom formatting. For now, this format looks okay. This looks good so far. We have repeated the same steps which we did in the last exercise. However, the summation over here of the values is not correct because here we are adding the US dollars from entity 1 with the Canadian dollars from the entity 2 and Australian dollars from entity 3, which is clearly not the right calculation. We will need to set up a new column in our data set which has values in a single group currency. To do that, we will first need to set up a mapping table that contains exchange rates for each currency that we are working with. So I'm going to set up a new sheet. I'll call it exchange rates mapping. First column is going to be currency. And in the second one, we'll have the rate. We are dealing with 3 currencies. So I'll mention them here. For US dollars, I'm going to put in 1 because we don't want to convert it. For Canadian dollar, I'll take the rate 1.23. And for Australian dollars, I'm going to take 1.40. I'll convert it into table and then load it into powerquery. I'll name it as currency mapping. Now in the consolidated query, I'll need to bring in the exchange rates. Once that's done, I can create another new column to calculate the amount in USD using those rates. To bring in the exchange rates, I'm going to use the merge query option. So I'll merge the consolidated query or the append query with the currency mapping based on these 2 columns. And now I'm going to bring in the rate. In the next step, we will use these exchange rates to calculate the values in US dollars. So I'm going to add a new column. I'll call it value USD. And in here, I'm going to use the value field. I can select the field from here as well. And I'm going to divide it by rate. I do not need the rate column anymore, so I'm going to delete that. And now we can load our queries into the pivot table. For the currency mapping query, I only want a connection, so I'll click on that. Now let's go to our pivot table. Here you can see we have the value in USD. So I'm going to remove the value and bring in the value in USD. Now all our numbers are in a consistent currency. Let's format them correctly. If we want, we can add quarters as well. Some of you might have noticed that in the last exercise, I used the same exchange rates to convert the values from both the years, that is 2023 as well as 2024, which in some cases might not be the correct approach because the rates keep on changing. So let's say we have different rates for different years, which we want to use for conversion. First of all, we will need to add these rates to our currency mapping table. So I'm going to add one more column to this table. Let's say these are the rates for 2024, and now I'm going to add rates for 2023. USD will still be 1 because we are converting from USD to USD, so we'll just keep a value of 1. For Canadian dollar, I'm just going to put in 1.15, and for Australian dollar, let's put 1.30. I'm using just dummy rates for an example. Actual rates could be different. Now, with the structure of this table changed, we might need to do some tweaks in our queries. First of all, I'm going to go back into the currency mapping query, and I can see that the new column has loaded in. I'll just convert it into text as well. And this column should be called year. With the structure of the currency mapping table now changed, we'll need to adjust our consolidated query as well. In the consolidation query, where we were merging with our currency mapping table, we'll have to modify the merge step. Earlier, we merged it based on the currency name only. But since the currency names are now repeated or are duplicated in the mapping table, this approach will duplicate the rows and can corrupt the data. As you can see here, the first row, which has the revenue, is already duplicated here. To fix this, we're going to merge using a combination of currency name and year, and it's very similar to how we use a combo lookup when working with the lookup formulas. So I'll go to the merge query step, click on the year icon over here. Instead of merging only on the basis of the currency name, I'll select currency name and year from the first table. And from the second table as well, I'll select the currency name and year. The combination of currency name and year does not have duplicates in the currency mapping table. So hopefully that will not duplicate or corrupt our consolidated data. I'll click on OK. Next, let's see the next step, which is expanding the merge queries. And the data looks fine. And now we're going to come to the last step, which works fine as well. We'll close and load. Let's refresh our table. Now let's check if our consolidation is applying the correct exchange rates for each year. I'm going to remove the quarter because we don't need it. And also, I'm going to filter the table only for the Canadian entity, which was entity 2. Also, I can just take any one line for now, which is revenue. And I will bring in both the values, value in local currency as well as in USD. Let's bring it in the same format. Now, by dividing the local amount by the USD amount, we can back calculate the rate that is being used for conversion. So I'll divide C7, which is the local amount, by D7. So for the year 2023, it is using a rate of 1.15. And for the year 2024, it's using 1.23, just as we had expected. In the last exercise, we used different exchange rates to convert values for different years. This approach works well for external reporting, but it's not always ideal for internal analysis. For example, let's say I want to calculate the revenue growth rates for 2024 versus 2023. I'll reorganize this table a little bit. I'll remove this one, and then I'm going to bring the values into rows, and I'll bring it into the same consistent format. So these are the values in local currency, and this one is in US dollar, which is converted at a different rate for different years. Now let's calculate the growth over here. So I'm going to divide D7 by C7. Here, the revenue growth rate in local currency is minus 1.33%. but when calculated using the USD values, it shows minus 7.75%. Ideally, they should be the same. But the difference between these two numbers is driven by currency depreciation and not the actual business performance. Basically, it's because if I calculate the exchange rates for 2023 and 2024, the numbers are getting converted at different rates. So although the underlying business performance was minus 1.33, but when we calculate using US dollars, there's a bit of a distortion coming due to the currency depreciation. In FP&A, we often compare scenarios, and we need our variances to reflect real operational changes, not the forex fluctuations. In such cases, it's better to use constant rates across the years or scenarios to get consistent and meaningful comparisons. In this video, I'll show you how you can include the both in your model. That is, reported forex values, which are calculated using actual or different yearly rates, and the constant forex values, in which the consolidated numbers are calculated using a single consistent rate across scenarios. In the currency mapping table, I will add two columns, one for the reported forex rate and another for the constant forex rate. In the reported forex rate column, I will keep different rates for different years like we have now. In the constant forex rate column, I will keep the same rate for each currency across both years. So I'm going to use the 2024 rates for both 2024 and 2023. Since we've updated the mapping table, we'll need to adjust our queries to reflect those changes. First, I'm going to open the currency mapping table query. To make sure it's loading correctly with all the updated columns, I'll go to the source. We don't need the change type step over here. We have all the columns in here. We just need to update their data types. So I'll first have it detect the data type, and for year, I'm gonna put it as a text. Next, in the consolidated query, we'll have to modify the merge step that connects to the currency mapping table. We'll still merge using the combination of year and currency, but this time, when we expand the table, we'll bring in both the constant rate and the reported rate columns. This will allow us to calculate both the reported forex and constant forex values side by side. I can delete this column now because it was calculating based on the previous rate. And after the expand currency mapping, I can add a new column. The first column will be value USD at reported forex. Here I'm going to take in the value and divide it by reported forex rate. Next, we will add a column which will be value USD at constant forex. Here I'm going to take in the value field and divide it by constant forex. We don't need the fields for constant forex and reported forex rates anymore, so I'm going to delete them. And also, for ease of understanding, I'm going to rename this column as value LCL. This basically means that this column has values in local currency. This column has value in USD at the reported forex, that is different rates for different years. And this one has values in USD at constant forex, that is all the numbers converted at the same rate. This change data type step will not work because some of the column names have changed, so we'll delete it. Also, we don't need this step. Lastly, we will just convert the data types ourselves manually. So this will be a decimal, and the remaining data types look correct. Now we're going to close and load. Let's go to our pivot table, which will clearly not work because a lot of fields have changed. So here we need the revenue and we need the local currency revenue. we need it in constant Forex, and we need it in reported Forex as well. Let's format it. Now let's calculate growth rates in all these three currencies. Using the constant currency rates, the growth rate matches the local currency result, which accurately reflects the underlying business performance. The growth rate based on the reported Forex, however, is distorted due to the exchange rate movements, and it can be misleading. If I include the results of the other entities as well, then also on the consolidated level, you should always rely on the growth rate that is calculated using the constant Forex, because it gives the more consistent and meaningful view of the overall group performance. In the last module, we learned how to consolidate numbers from different entities, giving management one complete picture of the business. But management isn't just interested in a consolidated picture. They want to know the story behind the numbers as well, and they also want to see how the performance is trending. For example, how much profit did we make this year and how does it compare to last year? Or how are we performing against our targets and our budgets? That is where variance analysis comes in. And variance analysis isn't just about subtracting this year's number from the last year or this year's number from the budget. It's also about understanding why the numbers have changed and actually what drove the movement. To do that, we'll need to break down the results into drivers and learn how to decompose the variances smartly. And since this is something FP&A teams do every single month, we'll learn how to set it up efficiently so you can focus less on the manual work and more on the insights. Let's get started. In this module, we're going to learn about variance analysis. Variance analysis is the bread and butter of financial planning and analysis field. Every corporation makes commitments to its shareholders, and the company's value and its stock price depends upon how well those commitments are delivered. That's where FP&A plays a crucial role. First, FP&A helps management define what are realistic commitments that can be given to the shareholders and to the stock markets. And after that, FP&A monitors the actual results and compares them to the targets that were set. Through variance analysis techniques, FP&A helps explain why the actual results might be different from the targets and how they can be fixed. In this module, we're going to learn about different variance analysis techniques. In the first lesson, we will use the exercise from the last example and calculate simple P&L variances. In the last exercise, we had consolidated P&Ls of three entities using powerquery. These entities were in different currencies. We're going to start this lesson from where we left in the last exercise. First of all, I'll rearrange the accounts and remove any filters from this table. Also, for this exercise, we're going to work with the USD values at constant Forex. So I'm going to remove the value in local currency, as well as the USD reported numbers. Let's do a bit of formatting. We now have a detailed P&L for 2024 and 2023. In this exercise, we will calculate variance for 2024 versus last year. Variance analysis can be done against any scenario. For example, you might be asked to do variance analysis of actuals versus the budget or target. The same concepts and techniques which you're going to learn in this exercise can be applied in all the cases. Here, we will focus on variance versus last year to keep the flow consistent with our previous lesson where we had built this P&L. To set up the variance calculations, we'll need to use Power Pivot and create DAX measures, which we learned about earlier in the course in the lecture on Power Pivot and DAX. So I'm going to reload this pivot table and add it to the data model to enable the Power Pivot. I'll open the queries. Then I'm going to reload this query. And this time, I'm going to add it to the data model. I'll load it as pivot table on the same location. Click on OK. Since we reloaded the pivot table, the previous table which we had set up is gone. Never mind, I will reset it up quickly. Also, I'm going to do a bit of a number formatting here. To calculate variances, we will need to set up three measures. One measure that has 2024 numbers, second for 2023 numbers, and third measure which has the difference between the two. This is similar to how we did the exercise in the video on Power Pivot and DAX. So I'm going to go to Power Pivot, create a new measure. We'll call it 2024 amount. We will use the calculate function similar to how we approached it in the previous exercise. I'll sum the amount in constant currency, where the year is equal to 2024. Check the formula, it's looking okay. Format it, and it's good to go. I'll remove the other fields now. Next, we're going to set up the second measure for 2023 amounts. We'll go to Manage Measures. I'm just going to copy the formula from 2024 measure because the formula for 2023 is going to be very similar. We'll just need to change the criteria. I'll add a new measure here, 2023 amount. Same exact formula as 2024 and just change the criteria to 2023. Check the formula, no errors, 1000 separator, well. And lastly, we will add a measure for variance, which will be amount 2024 minus amount 2023. Now we're going to add it to the pivot table. I'll also remove this slicer. This slicer was from the previous pivot table. If you want, we can add a new one. Now I'm going to add 2023 amounts and the variance. Let's do a bit of number formatting here. So in this exercise, we have set up a P&L variance analysis versus last year. In the next video, we're going to take it a step further and we'll learn how to deep dive into these variances. As FP&A professionals, our job isn't just to highlight what's the difference between the results of this year versus last year or versus the target. We also need to help management understand the why behind these variances. In this exercise, we'll explore how to deep dive into key variances to uncover what's driving them. In the previous lesson, we had built this basic P&L, which has a variance versus last year. Now we're going to focus on one line item that is revenue and analyze it in more detail. First of all, I'm going to add entity slicer to this pivot table. And I'm going to filter the results only for the US entity, which was entity 1. And here I can see the full P&L variance. And for the revenue, we can see that 2024 revenue is higher versus last year by $122,000. So we know the sales are higher versus last year, but the management will want to know why. Are the sales up because we sold more units, or because we raised prices, or because our sales mix shifted? What's the exact reason? Sales could be higher or lower due to three broad reasons. First is the volume variance, which means that we sold more number of units than last year. Second is the price variance, which means that we sold the same number of units as last year, but we sold them at a higher price. Third is the mix variance, which means that we've sold the same number of units and we sold it at the same price as last year, but more sales came from higher or lower priced items. Let's have a look at an example to get a further understanding of this. In this example, we're comparing actual revenue versus the budget. Actual revenues are $2,400 while the budget target was $2,500, so the revenue is lower by $100. Budgeted sales volume was 200 units, but in actuals we only sold 190 units, a shortfall of 10 units, mainly coming from product A. So we can say that the lower revenue is due to a volume variance of 10 units or $100. In the second example, the actual revenue is lower than the budget by $200. The total volume is the same, both are 200 units, in budget as well as in the actual results. But the product A sold at a price of $8 per unit instead of the budgeted price of $10 per unit. So even though the total volumes are unchanged, selling at a lower price caused the drop. So in this case, we're going to say that the revenue drop is driven due to unfavorable price variance. Now let's take a look at the last example. The total sales volume and prices both are same in both the scenarios, actuals and budget. The sales volume is 200 units, both in actual as well as the budget, and prices for individual products are also the same. But in spite of that, the total revenue is lower by $100. This happened because we sold more of product A and less of product B, meaning the sales mix has changed. We sold more of a cheaper product, which is product A in this case, and less of the expensive one, which is product B. Therefore, the resulting drop in revenue in this scenario is due to the mix variance or the mix impact. So to summarize, price, volume, and mix variances explain whether the revenue changes are driven by how much we sold, how we priced, or what we sold more of. Understanding which factor is driving the variance helps pinpoint the business driver and assign accountability. For example, if the sales dropped due to the lower prices, marketing teams may need to explain why they discounted heavily. If it's a volume issue, it could be tied to the sales execution or supply chain and production constraints. In practice, for most of the FP&A and analytical work, breaking revenue variance down into price and volume is usually sufficient to explain performance. It's simple and actionable, and the mix variance is not really required. So in the next exercise, we're going to learn how to calculate price and volume variances in Excel. Coming back to our P&L, we can see that the revenue has increased by $122,000. To understand what's driving this change, we'll need to break this variance down into its key components, that is price and volume. For that, we will need detailed breakdown of 2023 and 2024 revenue by product, including the sales volumes, prices, and total revenue. Here I have both the datasets. 2023 details, which has the details of quantity by product, as well as prices by product and the total revenue. And then I have the same sheet for 2024 details. First of all, we'll need to bring these two datasets together on one sheet. I've set up a new sheet called Variance Decomposition, where I have brought in these two datasets together. The first column shows the 2023 quantities. This is linked directly from the 2023 details sheet quantity column. Next is 2024 quantities, linked from the 2024 sheet. Same applies for the 2023 and 2024 revenue, each pulled from their respective source. The price per ton is calculated as revenue divided by volume for each of the years. Now we need to calculate the price effect and the volume effect, or price variance or the volume variance. The price effect or the price variance is calculated as the difference in price per tons between the two scenarios multiplied by the volume of the latest scenario, or in this case, it is a 2024 scenario. The volume effect is calculated as the difference between the volumes of the two scenarios multiplied by the price in the base scenario. And in this case, the base scenario is 2023. So I'm going to go ahead and calculate the price variance first. So the price of 2024 minus price in 2023 multiplied by the 2024, that is latest scenarios quantities. I'll drag this formula down. Then for volume, I'm going to take the volumes of the latest scenario minus volumes of the base scenario, which is 2023, multiply by the price of the base scenario, which is the 2023. I'll drag the formula down, and at the bottom, I'm going to add totals. The sum of price effect and the volume effect should explain the total difference in revenue of $122,000, and as well as it should explain the revenue difference on a product level as well. So towards the right, I'm going to add a check column to ensure that's the case. So I'll first take the difference between the 2024 revenue and 2023 revenue, and then I'm going to subtract the volume effect and the price effect. The answer should be 0. To highlight the products that are major drivers of price and volume effect, we can sort this table. I'll first add a row before the totals, otherwise that will also be included in the sort. Now I'm going to apply a filter to this entire table, and I'll first sort the price effect by largest to smallest. So here we can see that pizza is driving a price effect of $20,000 because the price of pizza increased from 101 last year to 116 this year. The second is cheese and shampoo. On the volume, we can also sort. The quantity of cheese sold increased from 2,090 tons to 2,300 tons approx, followed by shampoo, which also increased significantly in volume. So all in all, the increase in sales of $122,000 versus last year is mainly driven by increase in prices for pizza, cheese, and shampoo. The rise in volumes for cheese, shampoo, and nuts also had a major contribution. We can now take this analysis a step further and explore the business and economic reasons behind these changes. For example, we can check with the marketing team to understand what led to the price increase. For the volume uplift, we can discuss with the sales team. Was it due to the new customer acquisition, or was it due to general population growth? Further insights can come from different departments, but through variance analysis, we have converted data into useful information with which we can quickly identify the key drivers and pinpoint where to dig deeper. Great work so far. You've broken down the details of sales variance. But in real-world scenarios, things aren't always that straightforward. You'll often deal with new product launches or discontinued items which can cause your formulas to break. For example, let's have a look at the 2023 numbers. Let's assume that chips were newly launched in the year 2024. So I'm going to remove them from 2023 data. On 2024, chips are still there because they were newly launched. Likewise, cookies were sold in 2023, but let's assume for some business reason they were discontinued in 2024. So I'm going to remove cookies from the 2024 sheet. Now, if I return to the variance decomposition sheet, you will notice our formulas have broken down because there is no data for chips or cookies in one of the years. To fix this, we'll have to build error handling into our formulas. For price calculations, I'm going to use if-error formula to handle the missing data. So just before the formula, we're going to place an if-error function, which has two arguments. The first argument is the value or the formula that we want the function to evaluate. And in case if it results in an error, I will want to see a 0. Likewise, for 2024 as well, I'm going to build the same logic. And now I can drag the formulas down. Although errors have gone now, but our price effect and volume effect columns are getting a bit distorted because of the new launches and discontinued items. The impact of chips, which was a new launch in 2024, is coming all together in the price effect column, whereas the downside impact of the discontinuation of cookies is appearing under volume effect and distorting it. We can remove this noise from the price effect and volume effect and show the impact of new launches and discontinuations all together in a separate column. For the price effect and volume effect, I'll add an if condition so that if the price in either of the scenario is 0, the formula should return 0. Otherwise, this cell should return price effect as per the formula that we have already defined. So I'm going to put in if statement. In the first argument of if statement, I need to check if either of the price, either in 2024 or 2023, is 0. So I'm going to put an OR condition, open the bracket. The first logical argument is whether 2023 price is equal to 0. And the second logical argument is whether 2024 price is equal to 0. And if any of these conditions is true, which means that if any of the price is 0, then I want to return 0. Otherwise, I just want to return the price effect as per the formula that we had defined earlier. So I'll close the bracket, drag it all the way down, and now you will see that the impact of the new launches from chips has gone away. I'll do the same for the volume effect. If statement, OR statement, first we check if 2023 price is 0, then whether 2024 price is 0. If that's the case, return 0. Otherwise, return the volume effect as per the formula defined. And I'll bring it down. Now you can notice that the total variance check is not 0, which means that the total of price effect and volume effect does not fully explain the difference in revenue between the two scenarios. To fix that, we'll need to incorporate the impact of the discontinued items and the new launches. And to do that, we will create a separate column to capture the revenue impact from these items. So I'll call this column discontinued or new launches. Here, I'm also going to put an if statement. And first of all, check if price in any of the scenarios is 0. And if that's the case, I want to return the difference in revenue between the two scenarios. Otherwise, if the price is not 0 in any of the scenarios, then I'll need to return 0 over here, because it would already be captured by the price effect or the volume effect. Drag it down. Drag the sum formula as well. And in the total variance check, we will need to add the discontinued or new items impact as well here. Drag the formula, and there we go. So now we can see that the difference between the 2024 revenue and 2023 revenue is $181,000, out of which $66,000 is due to the price impact. These three items were the major price increases. $73,000 is the volume impact. The top three items which had the volume impact are here. And $41,000 was impact due to the discontinued items or new launches. Mainly, it's the new launch of chips, which drove extra revenue of $111,000. In summary, by building error handling formulas, you can ensure that your variance model remains robust even as your product portfolios change. That way, your model continues to work reliably no matter how often the products are added or removed. In the last few lessons, we learned how to decompose the sales variance. In the next few videos, we'll take it a step further and explore how to break down the profit variances. The approach to decompose the profit variance is slightly different. When we analyze the sales variances, we focused on the absolute change in revenue. For example, the difference between the 2024 and 2023 revenue was $122,000. So we broke this number down into the price and volume effects. But when analyzing the profit, it's more insightful to look at the profit percentages, also called the profit margins, rather than the absolute profit numbers. Let me first calculate the profit margins for these 2 years. So the profit margin is going to be absolute profit divided by revenue. The reason we focus on GP percentage is because the change in absolute gross profit can simply be a knock-on effect of the changes in sales revenue. For example, in this case, the profits have increased from $461,000 in 2023 to approximately $515,000 in 2024. But that's not necessarily a strong result. Sales also have grown by roughly the same percentage, so profit was anyway expected to rise. That's why GP percentage is the more meaningful metric. It reflects how efficiently the company is managing its costs and pricing its products. Let's take entity 3 for example, which I think was the Australian entity, but since we are working in USD at constant Forex, that shouldn't be a problem. Here, the absolute profit is increasing, but the margin is declining. That means that the profit isn't growing as fast as the sales. And this could indicate lower pricing, higher cost, or some other issue, something that we need to uncover by decomposing the variance. So in the upcoming exercise, we're going to decompose the variance between the 43.6% of 2023 and 41.1% of 2024.